Hello, very good evening. Hey everyone. Very good evening. Very good evening. Very good evening. Very good evening to all of you. Hey everyone. Am I audible? Right now, definitely I'm not visible, but everyone do. Hey, yes, everyone, do let me know. Am I audible? Am I audible to all of you? Welcome, vanakkam, suswagatam. जो बोले सोनिहाल सत श्रीकाल वालेकुम सलाम अस्सलाम वालेकुम. Welcome, vanakkam, suswagatam. Greetings, everyone. Namaskaram, namaste. Everyone, do let me know if Baba is perfectly audible as well as visible. Show me the green signal. If clearly audible, if you can hear me, can see me, show me the green signal. I want to see the green signal, kids. Wow, that's really fantastic. Let me check it out. Yes, that everything is fit and fine. And sorry for being 5 to 9 minutes late because of some technical glitch. So, thank you. Thank you. I can see everyone. Pranam, pranam. Very, very good evening. Suswagatam, suswagatam, suswagatam. Now, my dear students, how is everyone? First of all, do let me know how is my all future doctors and engineers. This is your Baba HSP over here. After a long time, now you can see the hydrocarbon chapter, the most important chapter for both, you can say, IIT, NEET, class 11th, class 12th, droppers, everyone who is preparing for J or NEET. This session is going to be very, very important. And whatever I'm going to tell you, I will stick particular to the NCERT. But before I start, show me the fire in the chat section if audio and video is 100% perfect. Yes. And just give me 1 second. Just give me 1 second. Just give me 1 second, kids. Just give me 1 second so that Baba can see. Just a second, kids. Just a second. Just a second, kids. Okay. Okay. Fine. Fantastic. Okay. Fine. Okay. So I'm going to start. Before I start, my dear students, if you're new to this channel, like, share, and subscribe. Everyone, it's your duty to mark your attendance. Your attendance in the form of smash the like button. I want to see you have to smash the like button. Everyone, just let me check it out. If everyone is going to smash the like button, definitely likes will get increased. One thing that whatever I'm telling you, you have to follow the rules. then only you are going to get the best, yes, thing that will stick to your memory. My dear students, yes, do let me know, have you marked your attendance in the form of like button? Yes, yes, you are the best students because you're following your Baba HSP. That's really awesome. Now see kids, here is hydrocarbon. Before I start hydrocarbon, let me tell you my dear students, this is Telegram link t.me/HSPN. HSPN Army, HSP molecules. So you can join this Telegram channel if you want to get information, right? Otherwise, you are already at or in the Telegram of Unacademy, right? So this is my Telegram channel. If you want to join it, you can join. Now, my dear friends, I will start from two things. Hydrocarbons. Today, Baba will let you know alkane and alkene. Alkane and alkene, right? And if I talk about alkane and alkene, I will tell you two things. These two things are really very, very important, and not these two things are important for alkene and alkene. Suppose if I am going to tell you about alkene, that will be the part of alkyl halide also. If I am going to tell you something about alkene's chemical property, that is going to be the part of alcohol also. People always thinking that. Students, all these students, they are having in their brain that chemistry pedicare customer. But I would like to say no. Ella, it's romba sulbam. Means chemistry is very easy. Once you get it in your hippocampus, then again and again in every chapter, it is repeating. My dear friends, once do it, you will see in class 12th NCERT, it will get repeated twice more. So 3 times. Are you getting my point? Everyone, what I can see in the chat, let me see in the chat, you are able to understand. But before that, let me tell you the preparation part, the chemical properties. These two things are very, very important. Plus, missing part of NCERT. Missing part of NCERT. Missing part of NCERT. This is really very, very important. It holds a hell lot of weightage because the thing which is very, very important for your NEET examination, JEE examination, but NCERT missed it. And once the things are missed by NCERT, my dear students, they are coming in your examination and they are being rank deciding. Yes, everyone agreed. Let me see the chat because from there I cannot see the chats. Let me see it from here, my dear students. So let me see the names. Who is ready, who is not ready? Let me check it out. Everything, my dear students. Yes, sir, dream batch students. Yes, all the students, whether you are dream batch, you are Avengers, you are Jaipur students, you are NEET Endgame students. Yes. Now, one kid is writing, voice is less audible. Okay, everyone do let me know. Just wait for a second. Okay. Now kids, now do let me know. Is the voice proper? Can you hear me? Can you see me properly, kids? Because audio should be perfect. Do let me know. Am I perfectly audible and visible? Let me see in the chats also. Yes, everyone, it's clear. Duration of the class. Yeah, perfect. It's perfect, kids. Let me tell you, my dear students, this alkane and alkene part, I will complete in 3 hours. 3 hours, Yes, you have to sit along with water. Sit along with water 3 hours duration. And I will tell you each and everything along with the tricks and whatever is written in your NCERT, I will let you know each and everything. Yes, everyone, hey, say yes, you are ready. So see what Baba is going to start. Baba is going to start from that portion which is missing in your NCERT. It is not given in NCERT. Let me tell you, this is missing in your NCERT. From where I'm going to start that first. Let me tell you the preparation of alkane. Preparation of alkane. And the first preparation, what I am going to tell you, that is missing in your NCERT. Hydrolysis of metal carbides. Now you will definitely say, sir, one metal carbides is given in your NCERT. What is that? If you have gone through your NCERT, one metal carbide is given in your NCERT. So this is not visible, I think. This is not visible or visible. This, whatever I have written in yellow, I think it's not visible. Let me write down with some other pen. Okay, let me use this. Okay, now it will be visible. Preparation of alkane. Hydrolysis of metal carbide. Which metal carbide is given in NCERT? That is calcium carbide. It is being mentioned, but that calcium carbide is for the preparation of what? Is for the preparation of what? If you have gone through NCERT, I want to see in the chat section, this calcium carbide is for the preparation of what? I want to see the answer in the chat section. So the answer will be acetylene. But you must be thinking, sir, right now you told us that you are going to teach us about the preparation of alkane, then this calcium carbide is for the preparation of alkyne. My dear students, 4 metal carbides. Number of times examiner has asked 4 metal carbides. How many metal carbides? 4 metal carbides. One is this calcium carbide. Always remember calcium carbide. And if you see, where is calcium? Beryllium, magnesium, calcium. These 3, and beryllium shows diagonal relationship with aluminium. So these 3 metal carbides, they are metal carbides. And hydrolysis reaction with water, what you are going to get, this is very, very important. 1, 2, 3, 4. Clear? 1, 2, 3, 4. Let me tell you, my dear students, this shows diagonal relationship with this. Diagonal relationship with this, my dear student. If you know diagonal relationship, you should know that this shows diagonal relationship with this. That means definitely these 2 carbides are important for alkane production, and these 2 gives alkynes. But for me, all 4 are important. Are you getting my point? They will produce alkane, and these 2 will produce alkyne. So it's like that. Not only alkane preparation, I will tell you all 4 metal carbides, whatever you are going to get in your examination, you should know, and they are not given in your NCERT. Only one metal carbide has been mentioned in your NCERT. That is what? calcium carbide. Now see, Baba is going to write all four. First of all, beryllium carbide, Be2C. Second one, aluminum carbide, Al4C3. If you react with water, remember that, my dear students, you will get alkane, that is CH4, and they will get dissolved in water. To form their hydroxides, but that is the side product not required. Side product, beryllium hydroxide, BeOH whole twice, AlOH whole thrice. So we got alkane. Now if I talk about calcium carbide, Ca2, already I have told you that this will give you acetylene plus calcium hydroxide as the side product. No one is going to ask. Now the question arises, magnesium. Remember that magnesium is more electronegative than calcium and smaller, so it will bind with more carbon. So Mg2C3, this is the formula of magnesium carbide plus water. This will give you propyne plus magnesium hydroxide. So number of times AIMS has asked these questions. JEE has asked this question number of times. Now is it clear? If it is clear, now show me the thumbs up or the green hearts if it is clear to all of you. All these four, if they are clear to all of you, my dear friends, I want to see green hearts in the chat section, that if it is being clear to each and every one of you, my dear friends. Yes, everyone. Yes, that's really fantastic. Very good. Awesome kids, awesome. It's really good. Now, my dear friends, second preparation, just see the preparation number 2. Hydrogenation. What? Hydrogenation. Now, why and how this hydrogenation is important, my dear friend? First of all, let me tell you, this hydrogenation word has come from that oil can be hydrogenated to give vanaspati ghee. Oil, unsaturated oils are unsaturated. If you react hydrogen, see, oil, if you react oil, what is oil? Oils are triesters of higher unsaturated fatty acids. Triesters of higher unsaturated fatty acids. Now, if you do the hydrogenation H2 in presence of catalyst like nickel or palladium or platinum, NiPDPT, plus 100 degrees Celsius temperature, you will get vanaspati ghee. What will you get? You will get vanaspati ghee. You know that vanaspati ghee, if the room temperature is not very high, that is semi-solid at room temperature, but oil is liquid at room temperature. My dear students, now here the temperature is used, so oil gets rancid or breaking of oil takes place and that becomes carcinogenic. So what people have done, they just to do this reaction at room temperature in presence of this, they have used Rane nickel. What I'm saying, what I'm telling you, Rane nickel, this is a very important question of all the examination. Rane nickel is an alloy of nickel and aluminum powder. That is an alloy of nickel plus aluminium powder. If this is used, the same reaction will take place at room temperature. What I am telling you, my dear students, if you are using Rane nickel, then the same product is possible at room temperature. The same reaction is possible at room temperature. So which one is better? This temperature, which is going to break this oil into parts which is carcinogenic, this one is better, or Rane nickel, which is doing the reaction at room temperature, that is better? Do let me know. The examiner can ask, what is Rane nickel? Rane nickel is nickel plus aluminium powder, not nitrogen. It's not nitrogen. Nickel plus aluminium powder, my dear students. Nickel plus aluminium powder. Are you getting it? Do let me know in the chat section that everyone, Rane nickel, Rane nickel, Rane nickel. Everyone got it, Rane nickel, kids. Do let me know in the chat section that yes, it is clear to each and everyone. Everyone, do let me know. Yes, 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 yes. Now, what I'm going to tell you another way, the hydrogenation. Let me tell you, my dear students, what is hydrogenation. Suppose you are provided with ethene and you are going to react with H2 in presence of catalyst. You will get CH3, CH3. Now, examiner can ask many questions based on this reaction. Let me tell you very frankly what. You know that this is gas, this is being gas, this is also gas. But can you see two types of molecules got converted into one type of molecule? The pi bond has broken. This pi bond has broken and converted into sigma bond. If I say one pi bond has broken and two new sigma bonds have been formed, not able to understand? Let me tell you. This pi bond has broken, and in place of this pi bond, if I write ethane like this, now see, this is one sigma bond, this is another sigma bond. Can you see? Two sigma bonds. And this reaction, pi bond has broken and sigma bonds, two sigma bonds have been formed. To break the bond, energy is required, and whenever new bond is got formed, energy is released. This is weaker bond. Weaker bond has broken and stronger bonds have been formed. So to break the bond, energy is required, and whenever the bond is formed, energy is released. Released is more, required is less. So overall, delta H will be endothermic or exothermic. This reaction will be endothermic or exothermic. So definitely it will be negative exothermic reaction. One point is clear, they can ask, this is exothermic, and whatever the energy is released, that is known as HOHO. HOHO. What is this HOHO? HOHO means heat of hydrogenation. Hey, hey. We call it hey, 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 but they call it HOHO. Heat of hydrogenation. Heat of hydrogenation. And number of questions will be asked on heat of hydrogenation. Now, two gaseous molecules got converted into one gaseous molecule. 2 crore will convert into 1 crore. 2 Arab will convert into 1 Arab. 2 moles, that is 6.023 into 10 to the power 23 into 2 will convert into 1 mole. Entropy is delta S, change in entropy is negative, that means decreased. So this is not in favor of this reaction, but this is in favor of this reaction. So overall, delta G will come out to be negative, my dear students, negative. Is it clear? So the reaction is feasible. Now, if this much is clear, then what type of questions they are going to ask, I will tell you. This reaction is in the surface chemistry. That how this reaction will take place, you will see this reaction's mechanism in surface chemistry. Let me tell you, because that is important. Suppose this is nickel as the catalyst, and nickel catalyst vacant d orbitals, sites, that is empty d orbitals. So this catalyst at this place, this alkene will get absorbed. This alkene will get absorbed, and at the same place hydrogen will also come. Hydrogen will also come. Hydrogen will also come like this. Or you can say hydrogen is already placed over here. Now hydrogen will start forming bond from the same side. This is syn addition or anti addition. It can go like this or it can go like this. Hydrogen is absorbed, alkene is absorbed, and they started forming bond. This is syn addition. Remember that syn addition means attack is from the same side. Now, why I am giving importance to this syn addition? Let me tell you. If your alkene is given like this, and another alkene is given like this, now this is being cis alkene, both the hydrogens are on same side, and this is being trans alkene. My dear students, this is being syn addition. This hydrogen here, the hydrogen, two hydrogens are about to add up. This hydrogen, because this is going to get add up from this side. Now this hydrogen can easily get added, and this hydrogen can easily get added. But over here you see this hydrogen and this hydrogen can easily get added, but this hydrogen will feel steric repulsion. Are you getting my point? This will repel, so this cannot easily attack. So whose hydrogenation is easy? Do let me know in the chat section whose hydrogenation is easy, cis one or the trans one, who can easily hydrogenate it. I want to see in the chat section, kids. I want to see in the chat section whose hydrogenation is easy, cis or trans. Fast. Everyone, I want to see your answer. If you are able to understand, then do let me know whose hydrogenation is easy. Fast, everyone, quick, cis. So remember that the heat of hydrogenation of cis is more than that of trans. HOH of cis is more than HOH of trans. This is very, very important. One thing is clear to all of you. Now, let me write down the whole story. That heat of hydrogenation in decreasing order, heat of hydrogenation in decreasing order. Just see, Baba is going to write heat of hydrogenation. So this is not substituted, will have maximum heat of hydrogenation. After this, mono substituted will have heat of hydrogenation, my dear students. After this, di-substituted. This is unsubstituted. This is mono substituted. Now in di-substituted, just see CH2. First of all, let me write down cis and trans. CH3, CH, double bond CH, CH3, and then CH2 double bond C and CH3, both the CH3 at this place, almost same. And after that, the trans one, CH3 H double bond CH, CH3. Just see, kids, this is cis and this carbon is having two hydrogens, that is having two methyl groups. They are the isomers, but see, 2-methyl at the same position. Now this is being trans-1. Now tri-substituted, and at the last tetra-substituted. Now I hope that this point is clear, very much clear to all of you. Everyone can get this point and everyone is able to understand this is the heat of hydrogenation, my dear students. If yes, always keep on showing fire or the hearts, so that from this much of distance Baba can understand. Yes, everyone is able to understand, because we are not getting that much of time to see again and again at the chat section, because from the distance this is not that much visible. Clear, kids? Keep on showing the hearts, fire, or whatever the things you can show. Now kids, see, remember that heat of hydrogenation is directly proportional to number of pi bonds. And remember that if pi bonds are equal, then heat of hydrogenation is inversely proportional to stability. But this second point is valid only when number of pi bonds are same. When number of pi bonds are same. Are you getting my point? The first point, always see at the first point and then see the second point. I hope that, oh my God, very good. Thank you. Thank you from my internal core of a heart. Yes, you are the good follower and brilliant students. Now see, let me give you question and try to solve it. Will you? I'm going to give you one question. I have told you first see this point, then go for the second point. Let's see whether you are able to solve it or not. Question is, arrange the following in decreasing order of HOH. Heat of hydrogenation. Okay. Now let's see. A is CH2 double bond CH double bond CH3. B is CH2 double bond CH2 double bond CH2. C is CH2 double bond CH2 CH3, and the D one is CH3 CH double bond CH2 CH3. I'm not going to give you the options. You have to write down the correct order. Let me check it out. Who is going to tell me the correct answer? Baba is waiting for your answer, kids. I want the correct answer. Baba is in need of correct answer, kids. The ball is in your court. Let me check it out. Whose answer is going to be 100% correct? Whose order is going to be the correct? Now let me see. Yes. Everyone, do let me know. Baba is waiting for your answer, kids. Let me check it out. Who is going to give the correct answer, kids? Yes. I'm waiting for your answer, kids. I'm just waiting for your answer. Everyone, do let me know. ABDC, everyone, ABDC, CB, CDBA. Bala is writing CBDA. Kids, Who will give the correct answer? Who is going to give the correct answer? I am waiting for your answer, kids. Just Baba is waiting for your answer, kids. Everyone, do let me know who is going to give the correct answer. I'm waiting for your answer, kids. Yes. Let me check it out. Who is going to give the correct answer, kids? Baba is waiting for your answer. Now see, everyone, what foreigners have done. Foreigners have done divide and rule. Whenever you are going to solve the question, you have to follow the strategy divide and rule. See, in A, how many pi bonds are there? 1 and 1. 2 pi bonds. 2 pi bonds. In B, 1 and 1. 2 pi bonds. Separate it out. 1 pi bond, 1 pi bond. 1 pi bond, 1 pi bond. Okay. Now, definitely, the compound which are having 2 pi bonds will have more heat of hydrogenation. That point is clear to all of you. Definitely the answer will be out of these two. These two are having 2 pi bonds. My dear friend, just see to it. Now, its pi bond is doing resonance. Pi, sigma, pi. Stabilized by resonance. This compound is stabilized by resonance. So, this is being more stable. More stable, and this is being less stable because pi bond, sigma, sigma and pi bond isolation is there. There is no conjugation, no resonance. So this is being unstable, my dear friends. So out of these two, which will have more heat of hydrogenation? B will have more than A. So B than A. Okay. Now see, 1 pi, this is having 2 alpha hydrogen atoms stabilized by hyperconjugation, and this is having 2 and 3, 5 alpha hydrogen atoms. This is more stable, this is less stable. So CD. C then D. How many of you got this answer? Then show me hearts, and if your answer is wrong, then show me fire. BACD. If your answer is BACD, then show me hearts. If your answer is not this one, then show me fire. Let me check it out. How many of you got the correct answer, kids? Everyone, do let me know. Hearts or fire? Hearts or fire? I want to see either hearts or fire. Yes, kids. Hearts or fire? Do let me know, kids. Hearts or fire? Yes. Yes, yes, kids. Some are saying, oh, some got correct answers, some got wrong answer. Oh my God. Okay, okay, okay. Okay, kids. Okay, fine, 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 fine. Okay. Just wait, 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 wait. Okay, okay, okay. Now, this is clear to all of you. Is this clear to all of you? Is this point clear to all of you? This will have maximum BA, then C, and at the last D. Right. Now see, kids. Now see, if the question is like this, mind-blowing question, let me give you mind-blowing. Question is, which compound will have maximum heat of hydrogenation per per molecule of H2 per molecule of H2. Just see the question. Reading properly and understanding the question means half done kids, right? So the options are A, CH2 double bond CH, CH double bond CH2. B is CH2 double bond CH, CH2 CH3, and C is CH3 CH3 double bond C CH3 and CH3, and the D option is CH3 CH double bond CH CH3. Just see the question properly. Read out question properly, my dear friend. Read it out properly and then do let me know what's your answer. I'm waiting for your answer, kids. Everyone, read it out properly. Let me underline it. This question is very, very important. Mostly, you can say this is the trap. Most of these students are going to get trapped in this question. Everyone, do let me know what's your answer, kids. Baba is waiting for your answer, kids. Yes. Everyone, do let me know, kids. I'm waiting for your answer. Yes, yes, yes. Everyone is going for A. Kids, read it out properly first. What I'm telling you, read out question properly, everyone. Kids, please read out properly. You're not reading it out properly, kids. Read it out properly, then answer it. Everyone, please read it out properly. Then only give the answer. Everyone, it's a humble request, kids. Humble request, kids. Read it out properly, then only answer it. Now see, kids, per molecule of H2, only one H2 is going to added, not two. If two H2 molecules are going to get added, then yes, definitely this should be the answer. But only one molecule of H2. So out of these, which is least stable, you see this is stabilized by resonance. This is having just 2 alpha hydrogen atoms. This is having 12 alpha hydrogen atoms. And this one is having 3 and 3, 6 alpha hydrogen atoms. So once you are talking for one molecule of H2, then the one who is least stable, so the answer will be definitely B. It's clear to all of you? If you are able to understand this question, because they have given per molecule of H2 or per mole of H2, they are giving question like this, then this should be the answer. Is it clear to all of you? Yes, you got it? Tell me in the chat section that you got it, then I can move ahead, kids. Everyone, do let me know in the chat section that you got it. Such type of question they can give you and you, yes, definitely you could get trapped. Everyone, do let me know in the chat section that you got it. You are able to understand. Very good. I can see that everyone is comfortable. Now see, the second preparation. Second preparation. From Rx, just see, alkyl halide Rx, where X can be chlorine, bromine, iodine, but X should not be fluorine, right? What you're supposed to do, react H2 in presence of zinc, HCl, then definitely what will you get? You will get RH. RH. Once they have asked question in year 2016, two times NEET was taken place. The question was like this. See, first they have done the chlorination of this Cl2H nu. I will tell you in the chemical properties. Benzo trichloride you will get if you are able to understand. Then they have done the ESR Cl2 anhydrous AlCl3. These reactions I am writing because still now I haven't told you, I haven't taught you. So this is reverse hyperconjugation minus H meta directing. You will get product like this CCl3 Cl, and then what they did, they have reacted this compound with H2 Zn HCl. Now my dear friend, this is arylic chlorine, will not go. Captain of the ship means strongly bonded with this carbon, will not go, but these are benzylic chlorine, weakly bonded, benzylic, so they will eliminate out and your answer will be metachlorotoluene. So this reaction was utilized in this shape, in this form. It's this the question asked in year 2016, and very, very important question. If everyone is able to understand, then yes, that's really fantastic. Now, from this Rx, there is one more way, that Rx, this is given in class 12th NCERT, use LiAlH4. This LiLH4, lithium aluminum hydride, is hydride donor. What? It is hydride donor. Now how to understand this is hydride donor and why it is being hydride donor? First let me write down the product, that this is hydride donor. Just think of, there was one LiH, lithium hydride, metal hydride, positive, negative. Metal was telling everyone, I can't handle this hydride, please take it, please take it. There was one AlH3. Aluminium in the outermost shell, 3 electrons, and it was bonded with 3 hydrogens. Even bonded with 3 hydrogens, its octet is not complete, it is just having 6 electrons in the valence shell. So aluminium was searching, hey God, please give me electron, please give me electron. So lithium said, hey, you are interested in electron, just take my hydride and keep it with yourself, live happily. So lithium has donated one hydride, means hydrogen along with electron, to him. So aluminium was very happy. Oh, I got electron, I got electron, I got electron, I got electron. Octet completed, 8 electrons. But aluminium's mama said, hey aluminium, what you have done? You are very, very small. You can't handle 4 valencies. You are small. Just have 3. You can't handle 4. Go and give it to someone else. So now aluminium is searching to donate hydride to get rid of this hydrogen, and so there was Rx. X was every day. X was saying, hey R, I will go away from your life, I will go away from your life. This was the polar bond. Cold War was going on. So when this Rx has seen LiAlH4, actually LiAlH4 is like this, LiAlH4 hydride donor. So it has donated hydride to this, and this has formed RH, and this is alkane. You got it? This is the story. If you liked it, you can show me some thumbs up. Okay, now my dear students, you liked it or not? Just do let me know, my dear students, the story. How was the story? Do let me know, my dear students. Let me have some water. You also keep yourself hydrated, my dear students. Okay. Now, This is preparation of alkane. Now, the very, very important preparation of alkane, the third one, Baba is going to tell you the third preparation. Just see. Third preparation. This is very, very important. This is Colway's electrolysis. Colway's electrolysis. You must have heard the name Colway's electrolysis. Have you heard this name, kids? Colway's electrolysis. Now, electrolysis is very big term, but I will give you one trick so that you can get alkane, alkene, alkyne just within fraction of seconds. How many of you want to know that trick? Baba HSP's trick. Baba is going to give you trick. Baba HSP's trick. So, within fraction of second with this Colway's electrolysis, you can make alkane, you can make alkene, and you can make alkyne. Just you have to blink your eyes and you will get all these three preparations. So, everyone ready? Is everyone ready? See, my dear students, see. Alkane preparation. First of all, I am going to tell you alkane preparation, okay? CH2, C double bond O, O, Na or K. CH2, C double bond O, O, Na or K. This is sodium succinate. If I remove sodium, this will be succinic acid. So, its name is sodium succinate, right? Sodium succinate. Because either they will give you the structure succinate or they will give you the name succinate. Its aqueous solution I am supposed to take HOH, HOH. This is aqueous. Now just give current. Current means supply electricity. Now see what is going to happen. Just see. Everyone, are you ready? Is everyone ready? See the trick. How it is going to work, kids. Break this bond. Da, 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 zing, 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 zing. Dig, 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 dig. Break this bond. Ding, 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 ding. Ding, 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 ding. This will separate out and this will separate out in this form. Just see CH2, ta, ta, ta. CH2, these two electrons will come over here. Ting, ting, ting. Now what is going to happen? This is going to take place. Ting, 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 ting. What is this? What is this? Kids, what is this? We got it. Ethene. Hey, everyone. We got it. Ethene. Now just see. Ting, ting, ting. Ting, 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 ting. Ting, 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 ting. 2 moles of carbon dioxide plus twice of carbon dioxide. These two, 1 mole of ethene, 2 mole of carbon dioxide, they are formed at anode. At anode. How many moles of gas is at anode, kids? 1, 2, 3 moles of gas is at anode. Now, in the solution, see in the solution, ding, 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 2 moles of NaOH in the solution, twice of NaOH in solution. So that will increase the pH of solution will keep on increasing. Ting, ting, ting. This is taking place in the solution, my dear friends. This is taking place in the solution. This is happening in the solution. Now what is left? Do let me know what is being left, kids. Everyone, do let me know. Ding, ding, show. Hydrogen gas H2 gas at cathode, at cathode, at cathode. Easy. 3 moles of gases at anode and 1 mole of gas at cathode. How is it? Hey kids, are you able to understand this trick or not? Do let me know. Is everyone able to understand the trick? Kids, do not decrease your energy level. Energy should remain same. Passion should remain same. Kids, do let me know everyone is able to understand this one. Show me some fire or the hearts if you're liking the trick. Now, let me give you another question. If the question is given like this, you have to tell me what is the answer. CH3, they have given you this question. CH, apply the trick and solve it. CH3, COOK, COOK, water, HOH, HOH. Supply the current. Yes. Now, what answer you are going to get? Do let me know in the chat section. What's your answer, kids? What's your answer? So, how to do it? How to do it? Break it from here. Form the bond. Form the bond. What type of bond will get formed? CH3. CH double bond CH. CH3. Butene plus 2 moles of carbon dioxide. This is taking place or getting formed at anode, my dear students, at anode. Now, 2 moles of KOH in the solution and hydrogen gas at anode. Is it clear? It is simple or not? It is being simple or not? You got it. In this way, you can prepare any product. Any product can be prepared. Now, see kids, alkene preparation. Just see alkene preparation. Alkene. CH. Sorry. This time I have prepared alkene, kids. That was not alkane. See, I have added the heading alkane. I think we are preparing alkene. Just see, I think I have added alkane preparation. We got alkene. Just see, alkene. This was alkene, right? Alkene, kids. I screwed up. Alkene. Alkene. We got alkene. See, this was alkene. We have prepared alkene. The heading by chance was alkane. By chance, the heading was alkane. I have prepared alkene. Is it okay, kids? First of all, do let me know. The heading was alkane. Everyone is able to understand, kids. First of all, do let me know. By chance, I have written heading as alkene. Now, I will prepare alkane. Everyone is able to understand, kids. Do let me know first of all. First of all, is it clear, kids? Yes, it's clear. Okay, that's clear. Now, after alkene preparation, now let me tell you alkane preparation. Just see alkane preparation. Alkane preparation. CH3, C double bond ONA, CH3, C double bond ONA, and aqueous solution, HOH, HOH. Can you see, kids? And the current. Now, this is sodium ethanoate. I can say sodium ethanoate or I can write sodium acetate. Is there any problem? No problem, kids. Now, see, sodium or potassium salts of carboxylic acid, of carboxylic acid. Okay, my dear friends. And this is the aqueous solution. Aqueous solution is necessary. Aqueous solution. Now, kids, same thing you have to apply. Just see, break the bond from here. Break the bond from here. What we have done earlier. The bond will break from here and the bond will start forming here. Are you getting my point? So, you will get CH3 and CH3. Ethane you have got. Now, 2 moles of carbon dioxide you will get CO2. CO2. You will get CO2. 2 moles of carbon dioxide, kids. So 3 moles of gases at anode, you will get 3 moles of gases at anode. In the solution, you will get NaOH, and at cathode, you will get hydrogen gas. I think this point is clear to all of you. And once again, the pH of the solution will keep on increasing because of NaOH formation. NaOH formation, 2 moles of NaOH in the solution. So pH will keep on increasing. Is it clear? Now, how to find out? See, kids, when I'm taking 2 moles of this, there is no bond in between this. One bond got increased. This is the new bond got increased. Can you see, kids? This is the new bond which has been formed. Already, you see, earlier what I have taken, already there was one bond. One bond was there in between carbons. So 2 bonds got formed. Now, you can understand already one bond was there in between carbons. So 2 bonds formed. No bond was there. One bond formed. Now, in the alkyne preparation, there will be already 2 bonds. So, one new bond will get formed. See, kids. See. Everyone see. Alkyne preparation. Just see. You apply your brain. Alkyne preparation, kids. Alkyne preparation, that means already 2 bonds will be there. Just see, 2 bonds are there. And one new bond will get formed. Are you getting my points, my dear students? Everyone getting my point or not? Let me know. Yes, 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 kids. Just see to it. You will supply current. You have to apply the same mechanism. Break the bond, break the bond, break the bond. If you're going to break the bond, in between this, one new bond will get formed. Already 2 bonds are there. And in between these 2 electrons, one new bond will definitely get formed. And this will be, yes, propine. You can, sorry, acetylene, CH, triple bond, CH, ethine or acetylene you can write. And 2 moles of carbon dioxide you will get anode. So 1 mole of this gas, 2 moles of that gas. At anode you are getting 3 moles of gases. In the solution you are getting KOH, and at cathode you got hydrogen gas, 1 mole of gas at cathode. My dear friends, do let me know. It has become, and what is the name? Potassium malate. What is the name of this compound? Potassium malate. Kids, everyone, if it is clear, yes, if you got it, if you like the trick, show me some hearts, fire, thumbs up. Yes, kids, Baba is waiting for your response. How much did you like it? This trick is really awesome. Coal-based electrolysis, no one can tell you in such a way, with such a simplicity. I have told you, kids. Do let me know. My dear friends, now let me read out the chat. How many of you are present? How many of you are absent? Let me see to it. Your wish, Sophie, Antraksh is there. Everyone write down in the chat section, are you enjoying the lecture or not? How much? Everyone, Sahana Darshini is there. Acid medium, don't take acidic medium. In this, for preparation, you have to take aqueous medium only. Now, let me check it out. How much you are getting, how much benefit you are getting from here. Sahana Darshini, Baba, you are the real God, Baba. Thank you. Antriksh from Nayan, thank you. Kanan enjoying, super. Sneha Maria, ignore. Hey Baba sir, can we prepare methane? No, in this method methane cannot be prepared. If you want to prepare methane, Baba is going to tell you, yeah, people are writing I'm weak, please help me. Jyoti Jain from Jaipur, lot of love. King of chemistry Baba. Sahana sir, wonderful. Laharika is there. Hi sir, how are you? Shivaji Baba is gone. Kids, keep on liking, keep on loving your Baba, and Baba is going to give you each and everything. So smash the like button, kids. Baba is here to give you the way how can you prepare methane. So hey, 10 but always keep yourself hydrated. Whatever your mama is going to give you for anything to eat, just go with that and keep yourself hydrated, right? Whenever I'm going to give question, I will provide you number of questions, then I will see the chat. Okay, so wait for that. Now, from carboxylic acid only there is one reaction named as soda lime reaction. Very important reaction, kids. Soda lime reaction. No exam starts without this. This is also known as decarboxylation. Very important. Decarboxylation, my dear friends. Decarboxylation, and this is also known as, or lab method preparation of alkane. Secrets. Lab method preparation of alkane. These are the three names which are given to this reaction. This holds a hell lot of weightage. Now let me tell you, my dear friends, just take what? R and 10 C double bond O H. In short, let me tell you what is going to happen. This carbon dioxide will get eliminated out. Ting. Now, this R will get negative charge and H is having delta positive. R is saying, hey, Inge va, please come over here. Come, Inge va. So, what will you get? You will get R, H plus zoom, carbon dioxide will get eliminated out. This is decarboxylation. Now, how it will be carried out, that is very tough. That we have to think that who is going to do all these things. So the agent is NaOH calcium oxide. NaOH is deliquescent and calcium oxide is hygroscopic. Deliquescent means the compound which will absorb moisture from the atmosphere, and calcium oxide is what? Hygroscopic. It will also absorb moisture from the atmosphere. But NaOH is deliquescent, it will become wet by absorbing water from the atmosphere, moisture from the atmosphere. But calcium oxide will not become wet. Are you getting my point? So, this is the catalyst and this is the reactant. How it is going to carry out this reaction, Baba is going to tell you on the next page. Just see, RCOOH will react with NaOH. Acid base neutralization will take place. ABN means acid base neutralization. You will get Rexona, RCOONA. Now once again NaOH will come along with the quicklime, calcium oxide. Now you will get RH plus Na2CO3. Now you can see in this reaction, my dear friends, one carbon got decreased, isn't it? There is shortening of the chain. You can see, my dear friends, there is what? The shortening of the chain has taken place. Shortening of chain is there. Shortening of chain by one carbon, One carbon means one carbon is less. Before I come to the mechanism of this reaction, let me tell you, my dear students, 2 times NaOH has been used. So that means NaOH should be given in excess. NaOH should be given in excess. That means what? If anyone is going to give you this compound, CH3, COONA, what it is known as sodium acetate. The name sodium acetate, very, very important, sodium acetate. And everyone, just see, if anyone is writing NaOH, quicklime CaO, if they are giving question like this, or if the question is given like in this way, CH3, COOH, NaOH, calcium oxide, or if the question is provided like this, CH3, COOH, NaOH excess, quicklime CaO, all the three, they will produce what, kids? They will produce what? The answer will remain same, and that is your methane gas CH4 plus Na2CO3. Everyone is able to understand, my dear students. In this way, methane can be prepared in the lab. Everyone, are you getting my point? Is it clear to all of you? Is it clear? Now, kids, if I give you question like this, benzoic acid, this is benzoic acid, everyone, you have to answer it. What product you are going to get? NaOH, calcium oxide. And somebody is giving second question, salicylic acid. Structure I am not going to give you. Salicylic acid, salicylic acid, and NaOH, calcium oxide. What will you get? Now I will check your answer. First answer, second answer. The ball is in your court, and Baba want to see your answer, kids. Yes. Now Baba is waiting for your answer, kids. Do let me know what's your answer. Everyone, do let me know what's your answer. Let me check out. Yes, everyone, do let me know what's your answer. One, rand, mono, nale, anche, are, benzene. First is benzene, right? First is being benzene. Absolutely correct. Satisfied. What is the second answer? Second. Benzaldehyde. Wrong. Benzaldehyde is wrong. Benzaldehyde is wrong, kids. Second answer. Now let me give you the structure of salicylic acid. OH, COOH. Now do let me know what's the answer. OHCOOH. Yes. Deepshika's answer is correct. This will be phenol or sodium phenoxide. Either phenol or you can say sodium phenoxide. Right? Everyone, this is the correct answer. Thanks for giving the correct answer, kids. Thank you. Thank you for giving the correct answer, kids. That's really awesome. Really awesome. Now, see, kids. Now, let me tell you, during this reaction, carbanion is the intermediate. Carbanion is the intermediate. This is a $1 million thing. You have to keep it in your brain. That rate of reaction is directly proportional to stability of carbanion. Rate of decarboxylation reaction is directly proportional to stability of carbanion. Stability of carbanion. Now, how the carbanion was produced, let me tell you. RCOOH, in the starting only I have shown you the reaction moves like this, R negative and H positive. Now, On the basis of this, how the question will be framed out in your examination. Are you ready for the question? Just see the question. Question is, just see everyone. Arrange the following. Arrange the following in decreasing order of relative rate of decarboxylation. Decarboxylation. Just see kids. See, options are A, CH3, CH2, COOH, first option. Second option, CH2, double bond CH, COOH. C, CH, triple bond C, COOH. And D, CH3, 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 COOH. What should be your answer, kids? I'm waiting for your answer. Do let me know. Everyone, do let me know what should be your answer. Now, just check it out. Your answer should be this carbanion is 1 degree, this carbanion and this carbanion. If you know, my dear students, the electronegativity of carbon, it is being 2.5, it is being 2.75, and this is being 3.25, and this is 3 degree carbanion. This is being 1 degree carbanion. This is being 3 degree carbanion. So, negative charge, if the size of atom is same, the size of atom is same, then negative charge is more stable on more electronegative atom, So, this is will lie at the last, this is maximum electronegative, so this will have maximum rate C, then B, then A, and at the last D. Kids, everyone, you are able to understand? If yes, do let me know this was your answer. That this will lie at the last. Maximum stable is this, then this, then this, and then that at the last. Kids, are you getting my point? Everyone, your answer is like this. Second question. Second question, if just I give you two compounds, compound A, if I give you compound A like this, CH3, CH2, COOH, and the compound number B like this, CH3, C double bond O, CH2, COOH. Now, which will have more rate? Which can easily undergo decarboxylation? Then the answer will be this one. Why this is the answer? Just see, it will take electron. This negative charge will do resonance. This carbanion is being resonance stabilized by resonance, and that's why one statement is given over there that beta keto acids undergoes decarboxylation simply on heating. See, this is beta keto acid. Just see, this is COH group, functional group is there. Adjacent to this is alpha carbon, this is beta carbon, so this is beta keto acid. So the statement is given over there, beta keto acids undergoes decarboxylation simply on heating, undergoes decarboxylation simply on heating. My dear student, Remember this point, and with the help of this point, you can solve any question, any question, any question. Let me show you this question kits. If they are going to give you question like this, now see to it, see to it. Simply they have given heat, no NaOH, nothing else is given. Simply they have given you heat. What will you do? Remember that this COH, this is alpha carbon, this is beta carbon, nothing over there, but this is also beta carbon. So this is being beta keto acid. If you can recall it, beta keto acid, what you are supposed to do, just remove CO2. You will get carbon ion and just add this H plus over there and you will get the answer. This is your answer, my dear students. Everyone got it? Is it clear to each and everyone? Once in the AIMS examination, they have given question like this. See, what question? If you don't know, let me write down first the thing which you don't know actually. Let me write down. They have given like this. They have given C2H5ONA got A, then the hydrolysis got B, and then B, they have heated and they ask C. What is C? Now, from B to C right now I am focusing because this one you don't know. Let me tell you. This is Claisen condensation because right now no one knows Claisen condensation. So I will do it for you. So this A will be CH3, C double bond O, CH2, COO, C2H5. And if you do the hydrolysis, with water it will react HOH. So this will eliminate out. Can you see, kids? This will eliminate out as alcohol and you will get acid CH3, C double bond O, CH2, COOH. Now number of students got failed because they were not able to remember Claisen condensation. Right now you don't know Claisen condensation, so it's not your fault. But here, if you're not able to recall, that's your fault. Alpha, beta, and if you're going to heat it, what will eliminate out? Definitely this carbon dioxide will eliminate out negative and positive. So your answer will be acetone. Is it clear to all of you, my dears? This is the preparation of alkane through soda lime reaction. Till now everyone is able to understand. Do let me know, my dear friends. Everyone got it? Now these are the preparations which I have told you from this and this. Now do you know any other preparation, my dear friends? That is from alkyl halide Woods reaction. Now Baba is going to tell you about the Woods reaction. Just see. Woods reaction. It's not Woods Khalifa. Woods reaction. Now my dear friend, what you are supposed to do, Rx, but remember that this should be either 1 degree or 2 degree. It should never be 3 degree. If you are going to take 3 degree, then what you will get, I will let you know. But remember that Rx should be either 1 degree or 2 degree. Then you have to react this Rx with Na and dry ether, sodium dry ether. Why ether? Ether is being polar aprotic solvent. Polar aprotic solvent. Now, how the reaction will proceed and what product you are going to get, let me tell you, my dear friends. Is everyone with full on energy or you got tired? First of all, do let me know. You got tired or you are with full josh and energy, my dear friends? Do let me know. Everyone, do let me know. Rx, X delta negative, R delta positive, twice of Na, Rx, R delta positive, X delta negative. Just see to it what you are going to get. Just remove out this twice of NaX. So the product, definitely you will get RR. R, this is being symmetrical alkane. plus twice of NaX. Is it clear to all of you? Is it clear to all of you? Now in this way, doubling of alkane is formed. Alkane is formed. That means if anyone is going to ask that methyl chloride is provided, kids, methyl chloride, Na dry ether, what will you get? What should be your answer? Dry ether, what should be your answer? If ethyl chloride is provided, then what should be your answer? If isopropyl chloride is provided, then what should be your answer? If this compound is provided, then what should be your answer? Chlorine and chlorine. What should be your answer? These are the 3 or 4. 1, 2, 3, 4. What should be your answer? It's just, I'm going to write down, try to find out. Here is your answer, CH3, CH3, then you're right. Here, if your answer is CH3, CH2, CH2, CH3, then you're right. Here, if your answer is CH3, CH, CH3, CH, CH3, CH3, then you are right. And here, if your answer is like this, then you are right. This is the new bond formed at this place. Then you are right. If all the 4 answers, all the 4 answers are like this, then definitely you are correct. You are absolutely correct. Now, just do let me know your answers. Let me check. Let me check. Your answers are like this or not, kids? Fast in the chat section. Do let me know. Your answers are like this only or not, kids? Fast. Be fast. Do let me know your answers are like this only or not, kids? No one. Fast, kids. Fast. I want to see your answer fast. Baba in endgame at 9 p.m. Oh, ho, ho, kids. What is this? Last one. Okay, last one. Kids, you can see. Okay, everyone. Now let me tell you the last one. Just see. One chlorine will go from here. One chlorine will go from there. Let me explain on the next page. Just see. Just see. It was given like this. It was already attached. It was already attached. It was already attached. Now see, kids. This was the chlorine and this was the chlorine. Chlorine will eliminate out. This chlorine will go. This chlorine will go. Now what will left behind over here? This 1 electron will left, 1 electron will left, and this 1 and 1 electron, what they will form? This 1 electron and that electron, they will form the bond. You got it? Now, if I give you one special question, then try to find it out. If anyone, just see, if they are going to give you this type of reactant, see, ClBr. Now, 2 things will originate. 2 things will come. See, kids, if they have given the freedom of this, then you know that this bond and this bond, this is weaker bond. This is being weaker bond and that is being a stronger bond. So what will happen? Just see, the reaction will move like this. The Cl at this place, Br at this place, one more molecule, Br at this place, Cl at this place, they will react with sodium, twice of sodium, and they will eliminate out. They will eliminate out to give you this product. Just see. Cl and Cl. See, kids, you will get this product. But at the same time, if they have given you just one equivalent kids, one equivalent of this, then how will you do the reaction? Just see kids, if they have mentioned only one equivalent, that means one equivalent only, my dear students, one equivalent only if they have given, that means what you're supposed to do, twice of Na dry ether. Now chlorine will go from that side and bromine will go from this side, and they will form the new bond. Just see, and very unstable bicyclo compound will get formed. Bicyclo compound will get formed, my dear friends. This will be the compound, and this is unstable bicyclo. Now you will ask why it is formed, because sodium is very reactive, explosive, and that's why reaction has to move in the forward direction. Now my dear friends, at this place, just see, I've told you that alkyl halide should be primary or secondary, but it should not be tertiary. If they are going to take tertiary alkyl halide, then what you will get, my dear student, just see, if by chance they have taken tertiary butyl bromide, by chance, now my dear students, you know that this is sterically hindered, so no Woods reaction will take place. The reaction definitely will take place, but it will not be Woods reaction. And what will happen? It will undergo disproportionation. Disproportionation is what, my dear friends? One carbon is undergoing oxidation, at the same time another carbon will undergo reduction. So one compound will be like this, isobutylene elimination, and another compound will be like this, CH3, CH, CH3, CH3, isobutane, my dear students, isobutane. Got it, everyone? So it will undergo disproportionation. Clear to all of you? Is it clear? Now, my dear students, these are the preparations by which we can prepare alkane. Now, there was one scientist named as Fittig. What he said? Fittig said, bro, I also want to give my contribution. Fittig, hey Fittig, what you want to give why you want to give your contribution? He said, please take aryl halide and react it with sodium and dry ether. Sodium and dry ether. So you will get biphenyl. Now both of them got publicity. Biphenyl, both of them got publicity. My dear student, both of them got publicity. Now, one worker has come, and that worker said, hey scientist, you are using sodium, and many of the workers got died. Because of sodium, there was explosion. Oh, his classmate heard this thing in the news, because the party was going on. And which party? Just see, in which party that worker has said, there was get together party was going off of Woods-Fittig reaction, that is known as Woods-Fittig reaction. In this party, what? Woods methyl chloride, aliphatic halide, Fittig aromatic halide, and the party of Woods and Fittig was going on, my dear friends. In this party, that worker blamed these people that you are using sodium, so many of the workers are not comfortable. And this news was heard by one scientist. His name was Frank Land. Then Frank Land came, and Frank Land said, I will give my contribution. Hey Franklin, scientist, what you want to say? So Franklin said, take RX, no problem, but use zinc in place of sodium so people will not die. So you will get RR and ZnX2, ZnX2. Oh, so my dear student, all these scientists, they are using some metal which is reactive. Once there was rain, zinc was destroyed. So one owl, in Hindi owl is known as Ullu, was listening and watching all these things. Now one day that Ullu owl said, I want to give my contribution, and that has become famous with the name of Ullman. Ullman. And he said, use vinyl iodide, my dear scientist, and don't use sodium or zinc, just use copper and heat. Copper and heat, then no problem will be there. Copper is highly stable, neither explosive nor going to get destroyed with the help of water, and in this way you can prepare. Now my dear students, let me tell you one thing. All these scientists, they have contribution for the preparation of symmetrical alkenes. There is symmetry. No one has tried to prepare unsymmetrical alkane, and that's why neither Woods reaction, Wittig reaction, Franklin reaction, the Ullman reaction is economical for unsymmetrical alkane preparation. Means the alkane who are having odd number of carbon. Let me tell you, my dear friends, what I am telling you. Let me write it down so that in the examination you will get full marks. Woods reaction is not economical for unsymmetrical alkane preparation. Unsymmetrical alkane preparation. Unsymmetrical means the alkane with odd number of alkane. Now we are not saying that unsymmetrical alkane cannot be prepared. What we are saying, it's not economical. Why it is not economical? Because everything is for money, minting money. Any industrialist is going to put whatever the efforts, they want to get money, the profit. Now see, here the profit will not come. See why? Suppose if you want to prepare propane, so you have to take methyl halide, you have to take ethyl halide. Now if you're going to take these two types of halides, what will happen? N number of molecules you are going to take. Suppose you are going to take 1 mole of methyl halide, 1 mole of ethyl halide, n number of molecules are there, 6.023 into 10 to the power 23 of this, 6.023 into 10 to the power 23 of that. So if this is going to combine with this, definitely you will get propane. Propane is a gas. Gas will fly. Now if this is undergoing self-Woods reaction, then you will get ethane. This is also gas. Gas will fly. If this is undergoing self, you will get butane, and that is also gas. Up to butane, they are being gases. And to separate this gaseous mixture, it will require too much amount of money, my dear friends. Gases can't be separated easily. If gases would have been possible to separate easily, then COVID pandemic time, you know, in the atmosphere there is oxygen, there is nitrogen, you would have separated out oxygen. Then what? Why the scarcity of oxygen cylinder was there? Because it's not so easy to separate out gases. Thank you, Sohana. Thank you, Sahana Darshini. So gases are very tough to be separated. Gases are very, very tough to be separated. Everyone, are you getting my point, kids? Do let me know. Do let me know. So that's why it is not economical to prepare unsymmetrical alkanes or the alkanes with odd number of carbon atoms. This is the preparation of alkane. Now Baba is going to deal with chemical properties of alkane. Are you ready? I want to see the heart in the chat section. Have some water. Have some water. Show me some hearts, kids, in the chat section. Then Baba is going to tell you chemical properties of alkanes. Fantastic, fantastic. Now, let's deal with chemical properties of alkanes. Now, my dear friends, there are number of chemical properties, but the chemical properties where you people find difficulty, Baba will deal with those chemical properties first, okay? Where you find difficulty, Baba will deal with those chemical properties. First of all, the most problematic thing is controlled oxidation. Am I right, kids? Controlled oxidation, this is the major problem. How to remember controlled oxidation? This is very tough, kids. Controlled oxidation. Now, before I give trick for controlled oxidation, let me tell you one thing. See, what is that? You know alcohol. If alcohols are getting oxidized, what will you get? If you do the oxidation of alcohol, what will you get, kids? What will you get? You will get aldehyde. You will get aldehyde. And if you further do the oxidation of aldehyde, what will you get? You will get acid. Okay. The oxidation of alcohol will provide aldehyde and oxidation of aldehyde will provide acid. Is it clear to all of you, kids? This you know very well. And if you don't know, then just you should keep this thing in your brain. Aldehyde and carboxylic acid, right? Now, my dear friends, Baba is going to give you one trick. Just remember that trick. Human man, chuck the taste, acid taste. Human man, chuck the taste, acid taste. What I'm saying? Human man, see, human man, human man. Everyone say, human man, human, not common man. Human man, human man. Chuck the taste. Chuck, 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 chuck. Chuck the taste. Acetate. Everyone say this. Human man, chuck the taste. Acetate. Everyone please say once, twice, thrice. Human man, chuck the taste. Acetate. Then you will get the code. See what is the trick. Human man, chuck the taste. Acetate. See, human. Q-S-C-U. Human. Molybdenum. MO2O3. Man, manganese acetate. This is manganese acetate. CH3. COO whole twice. Manganese. Now, what this code means? First of all, you have to keep this trick in your brain. Is this trick in your brain? Come on, man, chuck the taste. Acetate. Now, see, kids. See. If I take alkane, RCH3, And if I do the oxidation with copper and heat, I will get aldehyde. If I do reaction with molybdenum oxide MO2O3 heat, I will get this. And if I react with CH3 COO whole twice manganese and heat, I will get this. Just see, alcohol, aldehyde, carboxylic acid. Is it clear to all of you? Now, one more thing, my dear students. If you react this compound, this is the only compound which will react with KMnO4, KMnO4 and heat. This hydrogen will get removed, and in place of this hydrogen, you will get OH. Just see to it. CH3, CH3, CH3 and OH you will get, kids. You will get OH. Is it clear to all of you, kids? This is the controlled oxidation, because maximum people are afraid of this reaction and they are not having this thing in a brain. Now, second reaction, Baba will tell you, aromatization. Aromatization is also very, very important. People are afraid of aromatization. Just see, kids. Baba is going to tell you aromatization. Now, the question arises, what you will use in aromatization? If you are having NCERT, just keep your NCERT with yourself and see. If I take N-hexane, kids, N-hexane, CH3, CH2, 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 CH3, this is N-hexane. Now, hexane on aromatization definitely will give you what? It will give you benzene. Now, the question arises, what thing you have to use, and that you will never be able to remember. Now, remember the trick. Baba is going to give you the trick. The movie is of crore rupees. The movie is of crore rupees. What is the meaning of movie is of crore rupees? Crore, Cr2O3 plus 500 degrees Celsius temperature plus 20 atmospheric pressure. Crore. Movie means molybdenum oxide MO2O3 plus the same thing. Crore movie V2O5 plus this thing. Either this or this or this you can use. Now, NCERT has given one challenge, and that challenge is, if you are going to use N-heptane, then definitely the benzene is of 6 carbon atoms. So at the top of this benzene there should be CH3. So toluene will be the answer. I hope that everyone can get it, can understand. And the trick is, movie is of crore rupees. Movie is of crore rupees. How is the trick, kids? Do let me know how is the trick. Can I see what people are writing in the chat? Kids, how is the trick? Do you like the trick? If yes, if you're new, smash the like button, kids. Baba want to see more likes. The trick for this is crore rupees movie. Crore rupees movie. Movie is of crore rupees. Everyone, is it clear to all of you? Now, next thing in which people are afraid of, let me tell you, let me show you, my dear friends. That is what? Isomerization. They are afraid of isomerization, that what you are going to get. Isomerization. Now, in the isomerization, don't worry, kids. If they have given hexane and hexane, just see, and hexane, so 6 carbon atoms are there, and they are using anhydrous AlCl3. Anhydrous AlCl3. Just what you're supposed to do, kids. What you're supposed to do. You take out 5 carbons. You just take out 5 carbons, CH3, and anywhere you can place one methyl. One methyl. Now, how many are left? 5 are left. So, either you can place this methyl at this place, or you can place that methyl at this place. No need to worry about it, which is minor, which is major. There is nothing like that. So, you can see 2-methyl pentane, and this is being 3-methyl pentane. IUPAC 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just you have to put branch. So 2-methyl pentane, kids. Are you getting my point? Everyone. And this is being 3-methyl pentane. Everyone getting my point? 3-methyl pentane, kids. So now now you must be afraid of pyrolysis. How many of you are afraid of pyrolysis, kids? So Baba is going to tell you the pyrolysis. Pyrolysis, don't worry about the pyrolysis. It is very simple thing, kids. What you're supposed to do for the pyrolysis, just see. Pyrolysis. No need to worry about pyrolysis. Just see. Suppose if they have given you C6H14 and hexane. Now, one thing you have to remember, that pyrolysis takes place at 500 degrees Celsius to 700 degrees Celsius. This is very, very high temperature, because at 200 to 450 degrees Celsius or 500 degrees Celsius, that is free radical substitution reaction will take place. That I will tell you in detail before, because let me complete. These are very, very simple things. Let me complete these things, then I will go in detail, because the main chemical property of alkane is free radical substitution, and that is halogenation, chlorination and bromination. Maximum questions will come from there only, but these are also given in NCERT, so they hold a hell lot of weightage. So just what you're supposed to do, remove hydrogen from it. Anywhere, remove hydrogen. If you're going to remove hydrogen and breaking, pyrolysis means breaking of bigger molecules, breaking of bigger molecule into smaller one, bigger molecule into smaller molecule, smaller one. So if you break this and means dehydrogenation, remove hydrogen also. So this is of 6-membered. You can say you will get C4H8, butene you will get, right? You can write ethene, C2H4, butene plus ethene, 6 carbon. You can write pentene, C5H10. You can write C3H6, hexene, whatever, because it's not like that which will be in major amount, which will be in minor amount. These are the possible products. Alkene, whatever the alkene, lower than this carbon, lower than 6 carbon, any alkene you can form, and that should be the answer. Now, my dear student, Baba is going to tell you in detail about free radical substitution reaction of alkane, because that is the maximum thing which will come in exam. And if you're ready, show me fire in the chat section that free radical substitution reaction in alkanes, FR, SR, that is free radical substitution reaction in detail. Now, my dear students, before I start the free radical substitution reaction in detail, let me tell you one thing. The reactivity of halogens is in this order: fluorine, too much reactive; chlorine, bromine, and iodine, too slow. This is the reactivity order, kids. Now let me tell you this reactivity order. Whenever this reactivity order, Baba is reminding about this reactivity order, one thing always come to my mind. What is that, kids? F means father. F means father. And if you go to Maharashtra, I means mother. I means mother. In my time, I don't know what is the scene of today time. In my time, we were not going for shopping along with father. Father was saying, purchase this, buy this, that, and just move it out, move out, just move out. Very speedily, you do this and that shopping. Father was sometimes explosive, can't be controlled. Like father, fluorination is very speedily taking place, can't be controlled like father. Now, I'm not talking about father in today's world. My time's father, I'm talking about my time father. So, can't be controlled easily. Sometimes explosive. So, fluorination is not carried out. And if I talk about I, in my time, my mother was too slow. Too slow. 10 shops we are going to visit, and later on, my mother was saying, oh no, nothing I'm going to buy because I'm not liking. Next day I will come. I'm telling you about my time, mother, not today's mother, my time mother. So too slow, too slow. Poor yield, poor yield. Now, out of chlorination and bromination, maximum question will come from here only. Chlorination and bromination, I will tell you, this is more reactive, and the more reactive is less selective. I will give you numericals on this because number of questions will be asked. And this one is less reactive. I'm talking about bromine, less reactive, more selective. Before I move towards these questions, let me tell you simple, first of all, simple questions which can be asked in your examination, and then I will go in detail. Now, see kids, if I say the reactivity of fluorine, suppose if alkane is provided, and if I react with the fluorine, kids, in a dark, even in a dark, fluorine will kill this and will produce carbon black. Carbon black, my dear student, it will produce carbon black. Whether I carry out in dark, in sunlight, whatever. Now see kids, this is going to happen. But same reaction of methane, if I carry out with chlorine, and in dark, chlorine will say no, I will not react. No reaction. Now, chlorine, if I carry out chlorination in sunlight, or H nu is given, or 450 degrees Celsius, or tofu C, just remember tofu C. What is the meaning of tofu C? T for 200 to 400 or 500 degree Celsius, C for degrees Celsius, I will get methyl chloride, I will get dichloromethane, I will get chloroform, I will get carbon tetrachloride, 4 types of chlorinated product. Now, if I carry out this reaction in sunlight at 12 noon, here carbon black, once asked this question, carbon black, you will get carbon black. Just see to it, you will get carbon black. Cleared all of you? Now, let me tell you the mechanism how the chlorination or bromination is going to take place, kids. Are you ready? Is everyone ready, kids? Do let me know, is everyone ready? Show me some fire in the chat section so that Baba can understand that everyone is ready, kids. Fast, 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 kids. Fast. Because this is very, very important for your examination point of view, that how the free radical substitution reaction is going to take place. Just see, if I say there is one flask, and in this flask ethane is there, ethane, CH3, CH3 is there, chlorine is there, and dark, it's dark, nothing will happen, nothing will happen. Now sun will rise and the sun will give its sun rays, ding 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 ding. Either sun rays, this we will say photochemical reaction. Photochemically reaction is taking place, or heat, source of heat, then we will say thermally reaction is going to take place. Thermally, this is known as thermally. Either photochemically or thermally reaction can take place. If it is taking place thermally, then 200, 300 to 500 degrees Celsius temperature is required. And if it is taking place photochemically, then what can be given? H nu they can give you, or they can give you UV rays, or they can give you diffuse sunlight. Diffuse sunlight, right? Anything can be provided, my dear. Now, this is carbon-carbon bond, carbon. How many types of bonds are there, kids? One is chlorine-chlorine bond. One is carbon-carbon bond. One is carbon-hydrogen bond. 3 types of bonds are there. Now, which bond will break first? That is the $1,000,000 question, my dear friend. Which bond will break first? Now, see, this is carbon-carbon bond, highly stable carbon-carbon, because 2p pi or 2p, simply 2p bond, most stable because of catenation. Highly stable because of catenation, my dear friends. Highly stable because of catenation. Carbon hydrogen bond is stable, but there is electronegative difference. Carbon negative, H delta positive, but this bond is not having electronegativity difference. There is zero electronegativity difference, my dear friend. There is zero electronegativity difference, and it is 3p, the big bond, and this will break first. Till now, kids, everyone is able to understand why the chlorine is going to break first, because it is having poor overlapping, diffused overlapping. 3p is poor overlapping, and this bond will break first. And here the bond has to be broken with this mechanism, free radical equally division. So this bond will break first. Now, this step is known as chain initiation, my dear friends. Once the chlorine free radical or any free radical, that is known as first step, chain initiation. Everyone, chain initiation. Are you ready? Chain initiation. What is going to happen in chain initiation? Free radicals are generated. Free radicals are generated in this step. Now see how the free radicals will get generated, my dear friend. This is being chlorine, this is being chlorine. Now this will take its electron, this will take its electron, and the bond will break from here, and this is known as homolysis. Fish hook arrow, single arrow. This means fish hook arrow, fish hook arrow. This breaking is known as homolysis. What? Homolytic cleavage or homolysis. Lysis means breaking of bond. So you got 2 chlorine free radicals, 7 electrons in the valence shell. In the valence shell, there is no charge. No charge. Free radical is highly reactive entity. Everyone, just do let me know till now. Everyone is comfortable. Everyone is able to understand, my dear student. Do let me know in the chat section. I can see everyone. Do let me know, my dear friends. I want to see. Antriksh is there. Very good, Antriksh. Call everyone, Antriksh. Very good. Mr. Rajesh is there. Ripesh is there. Bhumika is there. Suresh is there. Salvadi is there. Fantastic, my dear friends. That's really awesome. That's really awesome. Very good. Very good. All my dear friend. That's fantastic. Now see, once the chlorine free radical is generated, now chlorine saying, oh, I am feeling unstable. What to do? What to do? Now this chlorine free radical will go in the second step, chain propagation step. Second step is being chain propagation. Chain propagation, my dear friend, chain propagation. Let's see what is going to happen. This chlorine free radical will approach this ethane. Hey ethane, how are you? Ethane will say, what happened to you? Who has done this thing to you? Now chlorine is unable to decide this should go for hydrogen or carbon. Now just see, if it is forming bond with carbon, it will be like this CH3, CH2Cl and H free radical we will get. But this bond is weaker bond. Experimentally, we got this as being weaker bond. So weaker bond will not get formed. So this chlorine will definitely form bond with hydrogen. It will react with hydrogen, my dear students, like this, and you will get this free radical. Now this is very, very important. Very, very important. This bond is stronger bond. In this way, you will get this free radical of substrate. Free radical is produced. And this carbon was having 8 electrons, stable, and the stable substrate, this is your substrate or reactant, and this substrate that is being reactant got converted to this free radical, and this is being unstable. Now my dear student, from stable to unstable, that means what? From stable to unstable, slowest step, and slowest step is rate determining step. Am I right, kids? Am I making sense? Everyone, are you getting it? Slowest step, RDS. Slowest step, and this is the point to be noted, my students. Slowest step, RDS, rate determining step. So remember that chain propagation will take place in 2 sub-steps. So this is sub-step number A. Sub-step number A. Now, after this, Baba is going to write sub-step B. But let me have a glass of water. Till now, if everyone is able to understand, wow, that's really fantastic. People are showing hearts. Sri Shant, thank you. Sri Shant, thank you. JK, thank you. Thank you. JK, thank you. Thank you, everyone, all my dear friends, for this love and support. Ram, 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 Ram. Now, kids, just see. In the sub-step, but remember that once the free radical is generated, rearrangement will never take place, but think about resonance. Whenever free radical is formed, always remember that whenever free radical is formed, always think about resonance. Always think about what? Think about resonance. Whenever I see free radical, whenever I'm in the beaker, I'm being the free radical, I'm in the beaker, I'm being the free radical, always thinking of resonance. I'm in the beaker, I'm being free radical, always thinking about resonance. Whenever free radical is formed, think about resonance. Then your question will always be correct. Now see, sub step A, sub step B. sub step B, just see sub step B, what is going to happen? That free radical will break Cl2 through free radical formation, and it will combine with this chlorine to form ethyl chloride as the answer. So one of the main product has been formed in the chain propagation, and this question has been asked number of times, that main product has been starting formed in the chain propagation sub step B. It has been formed. Now in chain termination, third step is being chain termination. See, chain termination, friends, chain termination. In this step, most of the free radicals are consumed. In this step, what is going to happen? Most of the free radicals consumed. In this step, most of the free radicals get consumed. How? Let's see. One thing, it could be like this: chlorine can combine with chlorine to form Cl2. Second thing could be like this: this ethyl free radical can combine with chlorine free radical to form C2H5Cl. Now, the third thing, this is in negligible or in traces, means in very, very less amount this is going to happen, that this free radical can combine with this free radical to form butane. Very, very rare. And second thing, disproportionation, that I will tell you on the next page. Everyone ready? Is everyone ready, kids? Disproportionation, I'm going to tell you on the next page because it will require understand. Disproportionation. What is the meaning of disproportionation, my dear friend? What is the meaning? That same atom is undergoing oxidation and same atom is undergoing reduction. Same atom is undergoing oxidation. Wow, my dear friends, thank you. Really, Vardhan. Wow. Carbon is undergoing oxidation as well as reduction. Carbon will undergo oxidation as well as reduction. Oxidation as well as reduction. Same atom is undergoing oxidation as well as reduction. See how, kid. If I say this is one molecule, now this is another molecule. Now my dear friends, just see, this is losing its hydrogen. Loss of hydrogen is oxidation, or you can say loss of electron is oxidation. Earlier days, hydrogen was important. Nowadays, electron is important. So either way you can say that it is oxidation, loss of hydrogen or loss of electron. This hydrogen, by taking this electron, is moving, ting 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 ting, hey carbon, I'm coming. Yes, it is going to that carbon. So it will be like this, see kids. This one bond was already there. Now this electron was free and this electron is free. Now they will combine together to form bond, and this is known as ethene. Ethene will get formed, my dear student, in traces. In AIMS exam they have asked, in IIT they have asked. Now this will go to this will form CH2H and CH3. the starting material ethane has been formed. Ethane has been formed. Can you see it? So these are formed in traces. Examiner can ask even what has been formed in traces. If this much is clear to all of you kids, do let me know that yes, this much is very much clear. Now, Baba is going to tell you something very, very important for the rank deciding. That is known as rank deciding. My dear friends, smash the like button. If you're new to this channel, smash the like. K Bhumika is saying once explain, sir. Okay. Bhumika ji, let me tell you, see, just see. This is ethyl, that is also ethyl free radical. This is losing hydrogen. This hydrogen with electron, loss of electron. This is loss of electron. Loss of electron. Anyone is losing electron, that is oxidation. Oxidation. This is gaining electron, gain of electron. That means it is undergoing reduction. It is undergoing reduction. Just see, by losing this electron will become free, and already it is having one electron free. This and this electron will combine together to form ethylene. Just see, ethylene. And this hydrogen along with the electron will come to this carbon, so it will form bond, and this is N. Can you see? Carbon is undergoing oxidation and carbon is undergoing reduction. So this is disproportionation, and all disproportionation reactions are redox, but all redox are not disproportionation. J Bhumika, you got it? Do let me know, is it clear, J Bhumika? J Bhumika, do let me know, is it clear to you or not? Do let me know, J Bhumika, is it clear? Now, my dear friends, if they are going to give you question like this, just see, question is very, very important question. Baba is going to tell you very, very important question. See, question is, on which carbon Cl2 will attack? Cl2 will attack. On which carbon Cl2 will attack? And the reactant is given like this. Reactant has been provided like this. See, CH3, CH3, double bond CH, CH3, Cl2H nu. And the marked carbons are X, Y, Z, and M. Now the ball is in your court, and I know that definitely you are going to get wrong answer. Let me tell you, my dear friend, answer is chlorine will attack on all four carbons. Answer is what? Chlorine will attack on all four carbon atoms. All four carbon atoms. Now see why and how. Should I explain why and how, kids? Should I explain why and how? You must be thinking, this carbon is vinylic and this carbon is not even having hydrogen, then how it will attack on this carbon? Let me explain, kids. Just see. Baba is going to tell you each and everything. Just see to it, kids. Just see it. Baba is going to tell you in detail each and everything. Just see. Wait and watch. Just see. CH3, CH3, double bond CH, CH2, no, CH3. These carbons are allylic carbons. You know very well allylic. Have you heard about allylic? Allylic means weakly bonded. This is allylic, this is allylic. These two are same. This is different. This is also being allylic. Allylic means sp3 hybridized carbon adjacent to double bonded carbon. So they will break easily. So if it is going, it will give you free radical like this. CH2 free radical, CH3, double bond CH and CH3. And if this is going, this will give you compound free radical like this, CH3, CH3, double bond CH, CH2 free radical. Now you must be thinking, sir, these two are formed, then definitely this was X, Y, Z and M. So free radical is only on M and it is being on X. Then how Y and Z? Then how Y and Z is possible? My dear students, I've told you, whenever you see free radical, I'm in the beaker looking at me. I'm in the free radical thinking about resonance. So if you're not able to understand resonance, if you're not able to do resonance, then you won't be able to get the correct answer. It will do resonance, gets the resonance. During resonance, it will switch over there and its resonating structure will be like this: CH2, double bond C, CH3, CH free radical CH3. Now see, the charge has come on Z carbon, the free, sorry, charge, not charge, free radical has come on this carbon, and if it is doing resonance, this will go over there, its resonance CH3, CH3, this free radical and CH double bond CH2. Now the free radical has come on Y carbon and this is being the most stable free radical, most stable, maximum form, maximum responsible for major product formation. Got it, kids? If I haven't told you this question, definitely you are going to miss this and you must have got negative marks. This is the best question. Everyone is going to make mistake over there. Everyone is going to, yes, definitely be in doubt that what should be the answer and how to do it. Now, my dear friend, let me tell you the most important thing, that relative reactivity and how to find out the percentage of product. Relative reactivity, my dear friend, that if I talk about Cl2 and if I talk about Br2, then definitely this is more reactive and less selective. Very, very important. Less selective. What is the meaning of that? And this is less reactive, more selective. My dear friends, whenever you are feeling very hungry, then suppose somebody has given you burger or pizza or samosa, you will put in the sauce samosa and you will start eating. Cut, 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 cut means you are hungry, very hungry. So you are less selective. And when you are not feeling too much in need of something, samosa like or whatever the burger like, you have done your breakfast, then you will say, oh, this is too much oily, and somebody has given the samosa, then you will throw the potatoes or you will throw that the upper layer and you will eat something, means some part of the samosa, or you can take sandwich, you will remove the outer part of the sandwich and you will take whatever you like. Am I right, kids? That you do or not do? So that means once you are more reactive, less selective, once you are less reactive, more selective. How the examiner will give you questions on the basis of this? Let's see. Let's see. if I say that we are having number of types of hydrogens on the basis of carbon, let's say this is I'm talking about chlorine and this is I'm talking about bromine, for their reactivity towards primary hydrogen attached to primary carbon, secondary hydrogen attached to secondary carbon, and tertiary attached to tertiary carbon. Now see the difference in the reactivity. If I say if its reactivity is 1, then 3.8 times more than 5 times more. But for bromine, the reactivity order, just see how much difference is there in its reactivity. If this is 1, then 82 times more than 1600 times more. See the difference. Now how the question can be asked, just see, this is going to be the rank deciding question. Everyone just see how this is experimental data. Baba is going to give you experimental data, my dear student. This is experimental data. Now see, if they are going to ask one question, just see the question is like this, that we are provided with propane. Now this propane is having, this is 1 degree carbon, that is also 1 degree carbon, and this is 2 degree carbon. So how many primary hydrogens are there? 3 and 3 primary hydrogens are 6, and secondary hydrogens are how many kids? Secondary hydrogens 2 in the reactant. We have to see in the reactant only the hydrogens, whatever the types of hydrogens I am telling you, because reactant only is going to react. Now they have done the chlorination. Just see, they have done the chlorination, Cl2H nu. Definitely we will get two types of structural isomers, two types of products. One is CH3, CH3, Cl, and another one we will get CH2Cl, CH2CH3. Is it okay? Now, which is major, which is minor, we can find out. But if they are interested in the percentage, how to find out the percentage? Suppose if I say this is X and that is Y, we can say X is major because 2 degree free radical is more stable than 1 degree free radical. Definitely the reaction must have proceeded with the formation of free radical. What type of free radical gets? Reaction must have proceeded with the formation of this free radical. This is 2 degree free radical and this is being 1 degree free radical. So definitely 2 degree free radical is more stable. This is more stable, more formed, more responsible for major product form. But my dear student, if anyone is asking find out the percentage of X, then what we will do? We will draw the line as usual we were doing in our school time to find out the percentage of marks, isn't it? Now what we have to do, we have to multiply by 100. This also we know, but what to write in the numerator? Just see here, the chlorine is attached to which carbon? 2 degree carbon, and 2 degree carbon, just see how many hydrogens in the reactant. 2 degree carbon is attached with 2 hydrogens, so I will write here 2. Why I have written 2? Because 2 hydrogens are 2 degree, and here I will write its reactivity. Here I will write its reactivity for 2 degree hydrogen. What was the reactivity? Just see, the reactivity was 3.8 times more than 1 degree, and it was 3.8. So I will write 3.8. Everyone, why I have written 3.8? 3.8 was the reactivity for 2 degree hydrogen, and these are 2 hydrogens which are 2 degree, right? Same thing I will copy over here, 2 into 3.8. Now I will put sign of plus. Now in this reactant, how many hydrogens are 1 degree? 6. 6 I will write. And what is the reactivity for 1 degree hydrogen? Just see, The reactivity for 1 degree hydrogen was 1. So I will write over here 1. So this is the percentage. Are you able to find out? Is this thing gone to your hippocampus or not? Kids, do let me know in the chat section. Is it clear? So how much it is going to come? Percentage of X. Find out. Apply maths. 2. 8 to the 16 and 3 to the 7. 7.6. 7.6 divided by 7.6 plus 6. 13.6 into 100, my dear students, into 100. How much you will get? How much you will get? Near about 56% approximately. Right, kids? 56% approximately. Are you getting my point? But same thing, if I have applied for bromination, then the answer should have been different. Now let me check the chat. Everyone is able to understand what to do when we feel demotivated. I will let you know. Surya, I will let you know. But right now, everyone do let me know this thing you are able to understand or not. Everyone, please do let me know and hit the like button. Smash the like button, kids. Make likes to be 500. Very good, Antriksh. Very good. Very good. Antriksh is very regular student. Now, see, my dear students, now where you are going to miss the marks. Let me tell you where you are going to miss the marks. Suppose if they have given compound like this. They have given compound like this. And if you do the chlorination, then do let me know, my dear student, which product you will get as major. I am going to write CH3, CCl, CH3, CH3. If I say this is X and this is being Y, do let me know which you will get in major amount. Kids, everyone do let me know. This is Y, that is X, which you will get as major. Definitely your answer will be wrong. Kids, do let me know. Then I will show that you are going to get wrong answer. Everyone, let me know what answer you are going to get in the chat section. Then definitely I will tell you that you are going to get wrong answer. Yeah, thank you, dude. 99.9 in JE. Shakti got 99.9 percentile. Surya Prakash, thank you, thank you. Why? Oh my God, kids are really intelligent. Kids, you are really intelligent. How do you know? How do you know? Definitely Y will be major because the percentage of Y will be 3. 9 hydrogens, 9 into 1. So 9 into 1 plus, this is only 1. So 5 into 1 into 100. So this is major, my dear students. You are really intelligent. You are really intelligent. Really. So this was all about alkane. Now, kids, Baba is going to start with alkene. Is everyone ready for the alkene preparation, kids? Do let me know. Is everyone ready for the alkene preparation? But before that, Baba is going to give you one mind map, right? Should I give you mind map first or should I tell you alkene first? Do let me know. Should I tell you alkene preparation first or should I give you the mind map first? What do you want first? So let me tell you alkene first or mind map. Let me know in the chat section. What do you want first? Mind map. Everyone is saying mind map. Okay. Just see. Baba is going to give you the mind map. Just see, everyone. Be ready for the mind map and see, everyone. Baba is going to give you the mind map. Everyone. $1 million mind map Baba is going to give. Just see. First mind map will start from methane, CH4. Now CH4 is going to react with Cl2 H nu. Just see everyone and try to recall in your brain all the reactions. What will you get? Methyl chloride. Everyone say along with me. Methyl chloride on reaction with twice of Na dry ether. Which reaction is this? Twice of Na dry ether. Do let me know. Twice of Na dry ether. Which reaction is this? My that reaction is Wurtz reaction. Wurtz reaction. Get ethane CH3 CH3 ethane you will get. Now once again do the chlorination H nu free radicals reaction Cl2 nu FrSR free radical substitution you will get 2H5 Cl. Now two ways are moving from here. One is you react it with alcoholic KOH alcoholic and heat, you will get CH2 double bond CH2 ethene. This is elimination reaction. And if you do react this ethyl chloride with KOH alcoholic heat, my dear friends, you will get alcoholic KOH, alcoholic, both are alcoholic. So I have screwed up here. You have to write aqueous KOH because alcoholic already I have used. Aqueous KOH will give you nucleophilic substitution reaction, and that has given elimination reaction. Elimination, this is substitution. You will get ethyl alcohol C2H5OH. From this ethyl alcohol, you can prepare this ethene when you react it with concentrated H2SO4 at 443 Kelvin, or you can convert it back when you react it with the dilute H2SO4. One is being hydration, one is being dehydration. This approach to alkene. This is dehydration, my dear friends. This is being dehydration. This is being hydration. Everyone, the writing is clear. Everyone, first of all, do let me know the writing is clear. Then only I will proceed ahead, kids. Do let me know in the chat section. Jai Baba ki Pratham, thank you. Pratham, thank you. Everyone, do let me know, is the writing clear? Is it clearly visible to all of you? Then I will make this memory chart. If the whatever I am writing, because it's very small, if it is clear to all of you, then only Baba is going to write. Kids, do let me know. Yes, yes, yes. Okay. Now, ethene, when reacted with bromine water, bromine's color is reddish brown, but this is being unsaturated. When it reacts with bromine water, the color will get decolorized and the compound formation will be CH2Br, CH2Br. My dear students, CH2Br, CH2Br, you have to react it with KOH alcoholic. When you are reacting it with KOH alcoholic and heat, my dear student, KOH alcoholic and heat, K positive will take away this Br negative charge, and this OH negative will take away its H plus proton. You see negative positive, sorry, here negative charge, so positive. Br negative has gone along with electrons, so positive charge, and here negative charge, negative and positive, they will form a bond. So you will get vinyl bromide. Now this vinyl bromide's lone pair is taking part in resonance, so this is very strong bond. This single bond is having double bond character, so alcoholic KOH can't take away this Br easily, so we have to use some stronger base, and stronger base is NaNH2. You see your NCRT, they have given NaNH2 heat. This is a stronger base. known as soda amide. Why this is being a stronger base, I will let you know. NH2 negative is formed from ammonia, and this is formed from water. Water is more acidic than ammonia. Ammonia is weakest acid. Weakest acid conjugate base is strongest base. My dear friends, what will you get here? You will get acetylene. Acetylene. Now, acetylene is very less reactive towards water, so you have to use catalyst. What the catalyst you are supposed to use? Hg2 plus and H plus, then you will get CH3CHO. Now do the oxidation of CH3CHO with KMnO4 acidic medium. KMnO4 acidic medium kits. You will get acetic acid. And now do the soda lime reaction. You will go back from where you have started. How is the memory chart? And this ethyl alcohol in class 12th you will study. If you reacted with PCC, it will convert into this back. And if you reacted with LiAlH4 or NaBH4, it will go back. How is the memory chart? This is the first mind map of hydrocarbon which I made for me in 94 kits. Do let me know. This will help in your conversion, and then I'm going to give you memory chart for alkene preparation as well as reaction. First memory chart for alkene Baba is going to give you. Kids, are you ready? First of all, do let me know how is this mind map. It's just I will take half an hour, that's it, half an hour. Now do let me know. In that memory chart, I will cover up alkene preparation and alkene reactions so that you can become master. I will consider all the reactions of NCERT in that memory chart. Do let me know, kids. Okay, now see, everyone see. Alkene memory chart, alkene reactions, alkene preparation and reaction. Just see. Are you ready, kids? If I say this is calcium carbide, I have taken calcium carbide. And if I react calcium carbide with water, if I do the reaction of calcium carbide with water, I will get what I will get, kids. If I react this with water, I will get acetylene, CH, triple bond, CH. Now, if I do the reaction of acetylene, two options are there with excess of sodium or NaNH2. Sodium 1 equivalent, if I am using 1 equivalent, then only one acidic hydrogen. These are acidic hydrogen because they are attached to sp hybridized carbon, so they are acidic. So I will get monosodium acetylide CNA, monosodium. And if I am using excess of Na or NaNH2, I will get Na, C, triple bond Na, disodium acetylide. Disodium acetylide. Okay, kids. Now, if I'm using methyl chloride, just see. If I'm using methyl chloride, excess of methyl chloride or 2 moles of methyl chloride, just see what is going to happen. CH3 Cl, CH3 Cl. So this is delta, it's negative and it is being positive. This is being delta negative, this being delta negative. So the bond will get formed. This will go along with Na, positive charge, this will go along with Na. Now what you will get, methyl will form bond with carbon, and this will be the bond formation from this side, everyone, I hope, is able to understand this, that we got higher alkyne. Now if this is being reacted with methyl chloride with excess or less amount, you will get only alkyne having acidic hydrogen. This alkyne is having acidic hydrogen, but there you got symmetrical alkyne. Till now you are able to understand. Now, my dear friend, Baba is going to give you that thing so that you will become perfect and intelligent, and your speed will definitely get increased. Now see, my dear friends, this is an alkyne, higher alkyne. Now two ways are going from here. Just see, two ways, one way and the second way. Baba is going to tell you both the ways. If you are reacting it with Lind-Lars catalyst, have you heard this name? Lind-Lars catalyst. Lind-Lars catalyst, that is H2PDC. This is according to NCERT, H2PDC. Otherwise, in books, it is given like H2PD, barium sulfate, charcoal, boiling xylene, quinoline. This much is given. Either this or that, whatever is given, this is being Lind-Lars catalyst, and it will give you cis alkene. Remember that. What will you get, kids? You will get cis alkene. You will get cis alkene. This you have to remember, cis alkene. But if you are using Na liquid ammonia, Na liquid ammonia, then this is known as Birch reduction. Birch, B-I-R-C-H, Birch reduction, and you will get trans alkene. My friends, you get trans. Now these many things I have covered up in this memory chart. Now do let me know, kids, you are able to understand or not. This is really awesome memory chart. Now after this, Baba is going to tell you the ozonolysis, because preparation I have told you. Now Baba is going to tell you, yes, dehydration I have told you, dehydrogenation I have told you. I've told you each and everything about alkene which is given in your NCERT. Only one thing is left, that is ozonolysis. Kids, are you getting help from this? Everyone do let me know, are you getting help from this? And now Baba is going to tell you in this memory chart one more thing which can be asked in exam. But before that, understand this trick. Everyone, if you understand this trick, then only you can understand that memory chart. TAM, Tushar, Kar, CSM. Just try to understand this trick. First learn it, then I will tell you the trick. TAM, Tushar, Kar, CSM. TAM, Tushar, Kar, CSM. Everyone say TAM, Tushar, Kar, CSM. What is the meaning of this? T for, yes, what is the meaning of T? Just apply your brain. Meaning of T, trans. Meaning of A, anti. Addition or elimination. M for meso. And meso is valid only when there is symmetry. Valid only when symmetry is there. When symmetry is there. Now, my dear student, this is being trans. This is being syn addition. This is being racemic mixture. This is being cis. Rest of the things repeating. TAM, Tushar, Kar, CSM, or just reverse of it, you can remember. TAM is matte. You can say matte, roasting on the matte, race, during race, and MSC, whatever you can remember, whatever is easy, you can remember. Which one is easy? TAM, Tushar, Kar, CSM, or matte roast, during race, matte roast, MSC. Which one is easy? You can remember that. Okay. Now, another thing is that what you have to remember, that Br2, whether it is addition or it is being elimination, that is always anti. What is the meaning of anti? That I will let you know later on during mechanism, but now you have to remember anti. Now, one thing, if you use Bayer's reagent, what is being Bayer's reagent? Bayer's reagent is, my dear friend, A, B. Bayer's reagent is 1% gold dilute alkaline KMnO4. This will do syn addition. Remember that syn addition. It will do syn addition. Anti addition, syn addition. On double bond, it will put two oxygens. On double bonded carbon, it will put two oxygens. Put two oxygens. That is it. And if you are able to learn these two things, one thing is that TAM Tusharkar CSM, and second thing is that it is anti and this is syn. Now Baba is going to give you the memory chart that will help you, that will give you full marks in any examination, whether it is of IIT JEE, IIT JEE Advanced, Mains or NEET, whatever the exam. So are you ready? Baba want to see the fire in the chat section, hearts and fire, then only this memory chart, mind map Baba is going to tell you. Otherwise, this mind map last year I have given for 19,000 rupees. Unacademy enrolled for these mind maps for 19,000 rupees. It was started with 3,000 and it was gone up to 58,000 even, right? 19 is the average. Now see kids, I have told you that calcium carbide has given whatever the acetylene, and this was your butane. From here, let me start this memory chart from butane. This was your butane, right? And how I have converted butane into two different things, that you know very well. I have converted this butane to cis butene, and I have converted this butane to trans butene. How I have done this? I have reacted this with the Lind-Lars catalyst. Lind-Lars catalyst, then it has given you what? It has given you in the chat section. Do let me know what you have got through Lind-Lars catalyst. You got CH3. Yes, do let me know what you have got. CH3, CH, double bond CH, CH3. Cis alkene you have got or not? You got cis alkene or not? Do let me know. You have got cis alkene or not? First of all, do let me know, kids. You have got cis alkene or not? You got cis alkene. Now, when you got trans alkene, how you have got trans alkene? Do let me know. When and how you got trans alkene? When you have reacted with sodium liquid ammonia. Am I right, kids? That we called it Birch reduction. Birch reduction. Now, my dear friends, you got trans alkene. Now, cis alkene, trans alkene. Now, if I react this cis alkene with Br2 carbon tetrachloride, do let me know. This Br2 will do anti-addition or syn addition. Don't apply brain. No need to apply brain, otherwise you won't be able to understand. Just to let me know, it will do anti-addition or syn addition. What kids are writing? Sahana, yes. Very good, Sahana. Antriksh, do let me know. Yes, Sahana, do let me know. JK, do let me know. Everyone, do let me know. Yes, very good, very good. Now, Br2CCl4 will do anti-addition or syn addition. Kids, do let me know. Br2 will do syn addition or anti-addition. I want to see kids in the chat section. Br2 will do syn addition or anti-addition. Anti-addition, that's really fantastic. You got it. Now, my dear students, if this is going to do anti-addition, this will do anti-addition. Now, just take CA, complete it. CA, how will you complete it? Do let me know. CA, do let me know how will you complete it. Get CA, CA, how will you complete it? Kids, do let me know. CA, what should I write? Car, racemic. CA, R, racemic I will get. Right, kids? Am I right? So, racemic means I will write down product like this. Racemic means I will write down product like this. Just see kids. I will write down product like this. One Br over here, one Br at this place, H, CH3, CH3. If you know what is a racemic mixture, that chiral carbon without any plane of symmetry. This is being racemic mixture. Is it clear to all of you kids? Such a great question. Without seeing any stereochemistry, you got the product. How many of you are able to understand? First of all, do let me know. Show me hearts in the chat section if you are able to understand, kids. This one, if you are able to understand, show me hearts. And let me tell you, my dear student, if you react it with the zinc and heat, that follows anti-elimination, you will get this product. Just see, zinc and heat, you will get this product. This is anti-elimination. Now, my dear student, let me tell you one interesting thing, that if you react this cis alkene with the Bayer's reagent, what Bayer's reagent is going to do? Syn or anti-addition? It will do syn addition. Bayer's reagent will do syn addition. Now, how will you complete this? CS, what should I write? CS, do let me know. What should I write? CS, CS, what should I complete it, kids? CSM, meso. I will get meso compound, my dear students. How the meso will look like? Just see. Meso will look like this with 2 OH. OH, OH. This is also having 2 chiral carbons, but along with 2 chiral carbons, it is having plane of symmetry, plane of symmetry. So this is meso, and it is optically inactive due to internal compensation. Till now, how many of you are able to understand, kids? Everyone got it? Now, here, Baba is going to do the bromination. Just see, if I do the bromination, that is anti-addition, anti-addition, and anti, just complete. Let me ask my dear friends, complete it. How will you complete it? Just to let me know what I am asking. TA, TA, TAM, meso. So how the meso will look like? Let's see. Meso will look like this. BR and BR, meso. BR, BR, H, CH3, CH3, 2 chiral carbon atoms. So meso. Now, if I do the reaction of this compound, my dear students, with what? Bayer's reagent. If I do react with the Bayer's reagent, what I will get? Bayer's reagent. But before that, if I react it back with zinc and heat, I will get back this compound. Now, Bayer's reagent will do syn addition, syn So TSR, Tushar, I will get Tushar. So I will get racemic mixture. Just see racemic mixture. Can you get it? That BR, no, sorry, OH, 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 H, H, CH3, CH3, OH, OH, H, H, CH3, CH3. I got racemic. So these tough questions you can do very easily if you remember this trick. How many of you are able to understand? Show me fire in the chat section if you are able to understand. Everyone, I can see Deepshikha, Sahana Darshini, that's really awesome. Aisu, really your answers, I'm loving your answers, my dear friends. 488, hit the like button, make it 500 kids. Only we are, oh, 494, only 6 likes are away from 500. We are just 6 likes away from 500. I need, yes kids. Now in this duration, just 20 minutes more kids, 20 minutes more, 20 minutes more kids, just 20 minutes more, 20 minutes more. Isomerism I have taught, isomerism I have taught for 12 hours. Now kids, Baba is going to tell you, after telling you all these things in detail, all these things in detail about alkenes. Now let me tell you ozonolysis. And before that, let me tell you simple words and simple technologies that preparation of alkene, because kids are not able to understand. See kids, preparation of alkene. How many methods are there for preparation of alkene? One thing I have told you, what's that? One thing I have told you, that Lindelar's catalyst, partial hydrogenation, already explained, isn't it, in the memory chart. Second is pitch reduction. This also have explained, right? Now, my dear students, there are 3 more ways by which you can prepare alkene. One is dehydrohalogenation. This I have told you in the memory chart, dehydrohalogenation. But I will give you one question based on this and I will solve it. Another thing is dehalogenation. This also have told you, but I will explain once again. Dehalogenation. And another thing is dehydration. I have explained this dehydration. I have explained this dehydration. All the 5 methods I have told you, isn't it kids? All the 5 methods I have told you. Now the turn is for ozonolysis, and ozonolysis of alkene, that is the chemical property. Now see kids, this is the preparation, and if I say the chemical properties, just see the chemical properties. If I talk about chemical properties or chemical reactions, just see kids, its chemical properties. If I deal with chemical properties, this is dehydrohalogenation. This is addition of HX, addition of HX first. Dehalogenation, I will say addition of X2, just reverse of it. And dehydration, I will say hydration, hydration, hydration. These are the chemical properties, just reverse of that, reverse of these 3, the chemical properties. So everyone is ready for the ozonolysis, my dear friends. Is everyone ready? But before I deal with ozonolysis, I would like to tell you Markovnikov's rule, and I will tell you, yes, Kharas effect. 2 things, Markovnikov's and anti-Markovnikov's rule before ozonolysis. Is everyone ready, kids? Is everyone ready? Is everyone ready, kids? So, first of all, Baba is going to tell you what Markovnikov's rule. Although Markovnikov's rule will get failed. Markovnikov's rule. What is this rule, kid? Markovnikov's rule. Let's see what is this rule. Suppose your alkene is unsymmetrical. Why it is unsymmetrical? Because this side CS3, that side no CS3. Unsymmetrical. If your reagent is also unsymmetrical, HBr, this is also unsymmetrical. Both are being unsymmetrical. Then the negative part of the reagent will go to that double bonded carbon which is having less number of hydrogen atoms. This is Markovnikov's rule. So your major product will be CH3, CH2, here hydrogen, here bromine. This will be your major product. But Markovnikov's rule will get failed during rearrangement. Let me tell you, my dear students, during rearrangement, Markovnikov's rule will get failed. During rearrangement, Markovnikov's rule will get failed. Markovnikov's rule will get failed. Will get failed, my dear students, will get failed. Let's see. Let me give you one example. Let me show you one example. Suppose if you are provided with compound like this, and now you are reacting with HBr. Just see, this is an example of hydrohalogenation electrophilic addition reaction, because this is a reactant, and this reactant or substrate is being nucleophilic. Why it is being nucleophilic? It is nucleophilic because of this pi electron, and here the H plus will attack first, and H plus will attack in such a way to produce more stable carbocation. So it will attack over here so that this carbocation should get produced. This will be the major carbocation till now. So you will get this carbocation, my dear student. Just remember this carbocation. And whenever the carbocation is formed, always think about rearrangement. Rearrangement means we are having something and we are feeling cold. Then we will put our shirts downside, and we are feeling more temperature, then we take our sleeves upside up. That is the rearrangement. So think about rearrangement. And if you move this hydrogen from this side to this side, this will be known as 1, 2 hydride shift. 1, 2 hydride shift means from one carbon H is moving to, not able to understand. Let me tell you in detail. This is a carbon, and this hydrogen will move to the adjacent carbon by taking electron. So this is known as hydride from one carbon to another carbon. Why it is moving? These two are same. Why this is moving? To give stability. Just see why and how. When the plus charge is on this carbon plus charge can do resonance with the benzene. This plus charge is doing resonance with the benzene, and we will say this is stabilized by resonance, SBr. So this is the most stable carbocation, and this formed in maximum amount, most stable carbocation rearrangement. Now, my dear friends, maximum bromide will attack on this carbocation only. So your major product will be this. This you have to mark in your examination as the major product. Now, my dear student, can you see? Those who will apply Markovnikov's rule, they will put Br at this place, Br at this place, but this is your minor answer, and those kids will definitely get failed because Markovnikov's rule itself got failed. So this is minor, this is major. See, whenever the rearrangement is going to take place, Markovnikov's rule always get failed. So always apply mechanism, never apply Markovnikov's rule. Everyone do let me know, are you able to understand or not? Now, my dear students, now let me explain Kharas effect, that is anti-Markovnikov's rule. Everyone ready? Are you ready? Is everyone ready, kids? Anti-Markovnikov's rule. This is also known as peroxide effect. This is also known as, kids, peroxide effect. This is also known as Kharas effect. Now, my dear students, three names are there. But remember one thing I am going to tell you. This anti-Markovnikov's rule, peroxide effect, Kharas effect will be followed when? It will only be followed with HBr plus peroxide. HBr plus peroxide. This is valid with this only. Valid with this only. If I say HF, HF, HCl, HI will always follow ionic mechanism, will always follow ionic mechanism. Ionic mechanism means what? No anti-Markovnikov's rule, whether peroxide is present or absent. Peroxide present or absent doesn't matter. Peroxide present or absent doesn't matter. Doesn't matter. Means will not follow anti-Markovnikov's rule. These will not follow anti-Markovnikov's rule. Will not follow Kharas effect, whether peroxide is present or absent. Right? Now, this will follow, and why this will follow, and what is Kharas effect, what is anti-Markovnikov's rule. Everyone ready? Is everyone ready for this? Very good. Let's see. If I say, my dear students, that I'm having this reactant and if I react this reactant with HCl and second HCl peroxide, what do you think? In both the two cases, what product I will get? CH3, CHCl, CH3, because it is following Markovnikov's rule. But if I say that I'm reacting it with HBr, once again it will follow Markovnikov's rule, that is ionic mechanism, BrCH3. Earlier one, let me tell you, this will follow free radical addition reaction. Free radical addition. Again and again, I am telling you they are following ionic mechanism. So Kras effect follows which mechanism? Free radical mechanism. Okay. Now see kids. If I take HBr peroxide, HBr peroxide, now it will follow anti-Markovnikov addition, and this Br will get added at this position. Just see, opposite to that, because here I am getting N-propyl bromide, N-propyl bromide. I am getting N-propyl bromide. And there I have got 2 bromopropane, 2 bromopropane. Got it? Now, how this reaction is going to take place? Now, you must be thinking, sir, HI also will not follow anti-Markovnikov, follow ionic mechanism also. Ionic mechanism only. HI or HI peroxide, whatever you are going to add. So, the mechanism of anti-Markovnikov's rule, that is Kras effect, is given in your NCERT. You want to understand? How many of you want to understand? Kids, hit the like button and show me thumbs up if you want to understand the mechanism. Everyone, those who are interested in mechanism. Yes, very good. I can see Sahana is very active. Rest of other students, Antriksh is very active. Rest of other students are also. Now see the mechanism. First of all, let me write down the reaction. Okay, CH3, CH double bond CH2 plus HBr and the peroxide. Generally, benzoyl peroxide is used because it is highly reactive. Benzoyl peroxide. How the benzoyl peroxide will look like, let me tell you. Benzoyl peroxide. Benzoyl peroxide will look like this. See why it is peroxide. -1, -1. So this is the reaction. Now let me explain the mechanism, kids. Mechanism. Now do let me know, everyone. Do let me know who will break first. Out of these 3 types of entities, 1, 1, 1. 3 types of entities, who is being least stable will break first. Definitely your answer should be peroxide because of -1, and this is the peroxide linkage. It will break first, and how it is going to break, just see. Everyone just see. It will break from here, homolytic cleavage, Fishhook arrow. Just see, Fishhook arrow, homolysis. Homolysis will be done. See it, homolysis. Now just see, everyone. It will give you compound like this, has broken C double bond O, O free radical. Can you see 2 molecules we have got? Now you know that you must have ever tried Pepsi, Coca-Cola, Thumbs Up, like that. And if you open the bottle and you close it, open it, close it, after 3 days you are going to have that Pepsi. You will not get that taste as the original taste. I'm not saying you should have this Pepsi and all. I never go for this. So those who are having it, they can understand that carbon dioxide will evolve. Carbon dioxide will go away. Carbon dioxide is very good living group, my dear friends. Carbon dioxide is very good living group. So it will evolve. It will get evolved. So what you will get? You will get 2 moles of Phenyl free radicals, although this is aromatic but highly unstable. Why it is highly unstable, my dear friends? Because the charge is on double bonded carbon, and whenever the charge, it's not charge, it is free radical. Whether charge of free radical, whatever is present on double bonded carbon, that makes compound highly unstable. So this is highly unstable. And this is being localized, can't do resonance, so this will go and attack on either this or this. So it's easy to attack on HBr. So on the next page, let me tell you, this phenyl free radical will attack on HBr and will opt hydrogen. It will make bond with this hydrogen and it will convert into benzene. Now who has become unstable? Now Br has become unstable. Now what this Br will do? Earlier peroxide was unstable, then phenyl free radical unstable. Now Br is unstable, and this Br will attack on this propene. This is left only. Now if I say this propene's numbering 1, 2, 3, double bond is in what I mean 1 and 2. So this Br can attack on first carbon. It is going to attack first carbon, or it can attack on second carbon. Let's see what two types of intermediates we will get. Br has attacked over here. We will get this free radical, and if Br has attacked that carbon, we will get this free radical. Now my dear student, if I say this is X free radical, this is Y free radical, which is more stable? Do let me know which is more stable. The X free radical is more stable or the Y free radical is more stable? Kids, do let me know. Everyone, do let me know. I can see. I want to see in the chat section that you are able to understand or not able to understand. Kids, do let me know which one is more stable. Fast. Everyone, fast. Do let me know which is more stable. Kids, why is more stable? Because you can see this is attached with one carbon. This is 1 degree free radical and this is 2 degree free radical. More stable, more formed. More stable, more formed. More responsible for major product formation, and this will react with HBr and it will take hydrogen from here, and it will get converted into this compound. Now my dear students, let me tell you something very interesting why this happens with HBr only. See why this happens with HBr only. If I tell you the thermodynamic data, that is very interesting thermodynamic data. Let me tell you the two steps. HF, HCl, HBr and HI. This Baba is going to give you thermodynamic data and the thermodynamic. Before telling you this thermodynamic data of the first step and second step, first step, the second step, my dear students, if suppose there are 4 type of students, those who are preparing for medical, they want to become doctor. The number 1 has become very successful doctor, but he doesn't want to treat patients. Is this of any use? First step is exothermic, Very easily he has become doctor, but don't want to treat patient. That means second step is endothermic, not of use. The fourth and third one, they have not become doctor, that they want to treat patient, of no use. They haven't become doctor, no, though, then who is going to get treatment from such type of people? First step endothermic, second exothermic. Now the second one has become doctor and want to treat patients. Both the steps are exothermic. Such type of people are only going to serve or help the society. Now see kids, if I talk about bond dissociation energy, then the bond dissociation energy is like this order. This is the order for bond dissociation energy, my dear friend. What I want to say, this has got maximum bond dissociation energy, and this has got least bond dissociation energy, right? So phenyl free radical cannot break HFNHCl, can't break HFNHCl, can't break, because that bond dissociation energy is high. Sorry. So can't be broken, can't be broken. So in this way I will write how, oh my god, sorry, HF, HCl, HBr, HI, this thing, how to write kids. Sorry. How to write in the thermodynamic factor, positive, positive. Sorry for the interruption, kids. Now, HF and HCl are saying if I would have been broken, then I like carbon, I would have formed very good sorry, bond with propene. I would have formed very good bond with propene, but you are not able to break me. So they are saying this step would have been very highly exothermic. My god, oh my god, so much. Sorry kids, sorry. Then I would have, that's, these two are saying, oh my god, I have not become doctor, I am unable to qualify the exam. If I would have become doctor, I would have served a lot to the public, right? Oof. Just a second, kids. Just a second. It's one thing is very clear about Baba, that whether Baba is feeling good or bad, Baba is very punctual. Baba will complete the whole lecture. After this, only ozonolysis is left. Baba will complete ozonolysis, then only Baba will complete this class. Okay? No, right now no one is over here, so I can't have coffee or tea. I'm alone. But kids, let me complete this. Then Baba will tell you ozonolysis. Now see, HI, the first step is exothermic. Easily HI is breaking. He has become doctor, but don't want to sub because carbon is 2p, carbon is very small, and iodine is 5p. This overlapping is very poor. So see, positive, negative, positive, negative, negative, positive. Only Br is the one whose both steps are negative, exothermic. That's why only with HBr this reaction is going to take place. Both steps are what? Both steps are exothermic. It's got it. This is the only HBr whose both these steps are exothermic. Everyone got it, kids? Everyone got it. This is the reason. Now Baba is going to tell you ozonolysis. My dear friend, those who are new, please hit the like button, smash the like button, and like our this lecture. Really, kids, this is for both, whether you say for medical, whether for JEE, all students, your brothers, sister, can follow, can see this lecture. Definitely, they are going to get a great help and easily they can solve any question. Let me see in the chat section what kids are writing. Ilamanthi, Chandrasekhar, thank you. Sahana, thank you. Srinath, thank you. It's really thanks for your love and support. You people always give a lot of respect to your Baba. Mr. BIP, okay. JK, thank you. Antaraksh, thank you. Jyoti Jain, thank you. Okay, let's start. Let's start, kids. Okay, let's start. The ozonolysis. Just see the ozonolysis. Just wait. Ozonolysis. Okay. Ozonolysis is of two types. One is reductive ozonolysis. Reductive ozonolysis. This you can do with O3, zinc and water. O3, zinc and water. Remember that in place of zinc, you can use dimethyl sulfide. Dimethyl sulfide can also be used. Dimethyl sulfide. Another type of ozonolysis is oxidative ozone. Oxidative. This is carried out with O3 and water only. O3 and right? O3 water. Let's deal with reductive ozonolysis because if you are able to understand reductive ozonolysis, then yes, oxidative ozonolysis also you can understand. Just seek it. Reductive ozonolysis first because this is very, very important for all type of exam. Right, kids? So please focus on reductive ozonolysis. Suppose if I'm going to take one alkene, C double bond C, R1, R2, R3, R4. And if I react it with ozone, my dear students, if I react it with ozone, then this pi bond will break. In the earlier days, this was used as a test for detection or detecting how many double bonds or pi bonds are present in the compound. Now see, my dear students, what you are going to get. R1, R2, C, R3, R4, and ozone will come like this. Now this is having peroxide linkage. Just see, peroxide linkage. The peroxide linkage will make compound unstable, unstable, unstable. This compound has become unstable. Unstable due to peroxide link. Now, if this is known as monoozonide, what do you call this compound? Monoozonide. Monoozonide. Now, when you react this compound with zinc and water, what is going to happen? See, kids. This carbon is saying, I will keep one oxygen. This carbon is saying, I will keep one oxygen. Now, this one oxygen is left. Zinc is saying, I will take away this oxygen and I will convert into ZnO. And these compounds will get converted into compounds like this. R1, R2, R3, R4. So this is the final product. Now, my dear students, in the examination, you will not get this much of time so that you can do all these things. We have to be very fast. Now, see how to get speed in the examination. Directly, you just see. I will let you know how to do it, the examination. So, speedily you can get the answer. So, you will say, oh, wow effect. You will feel wow effect. Just see it. You will feel wow effect. O3, zinc, water, just along with sigma bond break pi bond, and in place of this you just remove it and insert oxygen. Just see, this is so simple. Now if you want to go back from this, just add it, remove oxygen, you will get final product. So this is the speedily process speed, just along with sigma bond break pi bond and put over there oxygen. Is this easy? Now let me give you some questions so that you can understand it. Just see it. Let me give you some questions so that you can easily understand it, my dear students. Just see it. Just see it. CH2 double bond CH2. And if you do reductive ozonolysis, O3, zinc and water, just find out what product you will get. CH3, CH double bond CH, CH3, 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 C double bond CH3, CH3. In all these three, what product you will get, just to let me know. So definitely your answer will be, my dear friends, yes, your answer will be 2 moles of formaldehyde, right? Your answer will be 2 moles of acetaldehyde, right? your answer will be 2 moles of acetone, right? Now, with the help of these 3 reactions, you have done ozonolysis, but you have learned one more thing. What is that? Whenever the symmetrical alkene is there, you will get only one type of product. Whenever symmetrical alkene is there, you will get only one type of carbonyl product. Or vice versa, we can say if we are getting only one type of carbonyl product, that means the alkene must be symmetrical in the examination. This data will help you a lot, my dear. If you are having symmetrical alkene, you are going to get only one type of carbonyl product. If only one type of carbonyl product is obtained, that means the alkene must be symmetrical. Am I right? By chance, they are going to give you a question like this. An organic compound on ozonolysis, O3, zinc and water has produced propanol. Propanol. Now, what is the IUPAC name of this compound? They're asking about the IUPAC name of this compound, my dear friend. They are asking IUPAC. Now, what you are supposed to do? It's very simple that you write down propanol. This is your propanol, you know, because this is given in the question. Now, only one type of product, that means this is symmetrical. So, just combine 2 propanol in this way and remove oxygen. This only I have told you to do. Remove oxygen. Once the oxygen is removed, what do you get? CH3, CH2, CH double bond CH, CH2, CH3. Am I right, kid? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 5, 6. Hex 3 in. Hex 3 in. Kids, this question is simple or tough? Do let me know. With this trick, this question has become very simple. My dear friends, do let me know you are able to understand. Let me see in the chat section what kids are saying. Do let me know, kids. Everyone, do let me know, kids. X3 in. Very good, kids. You can see the answer. That's really awesome. Kids are really doing their best efforts. Fantastic, Chiku, JC, Tipati, Rishita. You kids, really you are doing great job. Great job. Jyoti Jain, very good, kid. Very good. Now see, kids. Once if you have done this, let me tell you, if you are having benzene, you are provided with benzene, what will you get on reductive ozonolysis? Do let me know. You are provided with benzene and they have given, write down O3, zinc and water. What will you get, kids? What should be the answer? Now, definitely, how to solve it? See. All the carbons are CH, 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 CH. You break them, it will break from here, break from here, break from here. Now, what will you get, kids? You will get CH, CH, double bond O, double bond O, CH, double bond O, double bond O, CH, double bond O, double bond O. Can you see? Known as glyoxyl. 3 moles of glyoxal, my dear friends. 3 moles of glyoxal you will get. That's really awesome, really awesome. 3 moles. But my dear friends, if they once they have given an AIMS and IIT this question, tough question. Orthoxylene. They have given orthoxylene. Ozonolysis. What is orthoxylene? Orthoxylene is like this. Now on ozonolysis, how many types of carbonyl products you will get? That was the question. Let me know how many types of carbonyl product you will get. How many types of carbonyl product? This is the question, my dear student. This is the question, $1,000,000 question, and let me check it out. How many of you can give the answer? I'm waiting for your answer, kids. Just do let me know how many types of. Do let me know, kids. Yes, everyone, do let me know how many types of products will you get, kids. So let me tell you how to do it. Otherwise, you won't be able to do. See, the fundamental thing is that only they wanted to ask that do you know or you don't know that the double bond in benzene is not fixed, that is always rotating. That is the thing. They are just interested in that. And if you apply this thing, then definitely you are nearest to the answer. Just see, kids. If I break this, it will break from here, it will break from here, it will break from here. So it will break, this will remain joined. So what I will get, O3, zinc and water, I will get definitely carbon CH3, double bondo, 2-methylone glyoxal. So I will write dimethyl glyoxal. Now this will be joined with this carbon. So CHO, and I will get CHO, 2 moles of CH double bondo, CH double bondo. I get like this, break from here. So this is glyoxal. I got 2 types of molecules at this place. Now let me see from here what I will get. I will break it from here. So this will break here from here. It will remain attached at this place. And this will remain attached at this place. Just see. So I will get CH3, C double bondo, CH3, C double bondo, CH3, C double bondo, and CHO. Just see. CH double bondo, 2 molecules of this. This is known as one side, means methyl glyoxal. Now, my dear student, this will be glyoxal. So, total types of products, how many types of product I have got in total? I've got 3 types: dimethyl glyoxal, methyl glyoxal, and glyoxal. So, answer is 3 types. Answer is 3 types. Got it, kids? 3 types. We got 3 types. Everyone, let me check it out in the chat section that it's only 5 minutes. Only 5 minutes. Varun, not 4 types, only 3 types. Varun, just 5 minutes. Okay. Sahana, right. Dr. Ilamantri, right. Dipati, right. Varun, don't sleep. Okay. Varun, just 5 minutes. Okay. Now let me tell you oxidative ozonolysis. Tickets. Oxidate. Just see oxidative one. Okay, kids? Only 5 minutes. Baba is going to take 5 minutes on. Just see. See, in oxidative ozonolysis, my dear friends, if you are using the same compound C double bond C, R1, R2, R3, R4, ozonide will get formed. C, R1, R2, R3, R4, ozone, oxygen. Now, zinc you are not using. You are not using zinc. Only H2O you are using. So, what is going to happen? One oxygen, this carbon, one oxygen, this carbon, and rest of the one oxygen will be taken by water, will convert into H2O2. This is mild oxidizing agent. Mild oxidizing agent, kids. Now, this mild oxidizing agent will play its role. How it will play its role on these compounds which have been formed? Let me write down those products which have been formed. R1, R2, C double bond O, C double bond O, R3 and R4. Now, on these compounds, who is going to attack? The H2O2 will attack. Let's see the help of H2O2 attack, where they will get changed. That's just the point. Noted, my lord. See, role of H2O2. Role of H2O2. That is the point. Now, my dear students, if aldehyde is formed, aldehyde, the two products out of those, aldehyde, then H2O2 will oxidize aldehyde and will convert it into carboxylic, make it to carboxylic. And it is saying that if the aldehyde is formaldehyde, then what I will do? Point to be noted, my lord. If this aldehyde is formaldehyde, first it will oxidize it to formic acid HC double bond OOH, and this is the only carboxylic acid which is having CHO group. The only carboxylic acid with CHO group. Once again, it will oxidize it up to carbon dioxide and water, form CO2 and water. And H2O2 can't do anything to ketone. If they are ketone, no effect on ketone. H2O2 have no effect on, they will remain safe. Now, my dear students, if you are able to understand, then I will give you question and try to solve it so that we can understand that yes, you got it. Just see, the question is CH3, CH double bond C, CH3, CH3, O3 and water, O3. See, there is no zinc, no zinc. So this is oxidative ozonolysis. So you just try to think what you will get. First you will break it. You will get CH3, CH double bond O, and acetone you will get CH3, CH3, C double bond O. Now H2O2 will attack on this hydrogen peroxide and will convert it into acetic acid. One product is acetic acid. H2O2 will try to attack on this. This will say, oh, I'm the ketone, can't do anything to me. So, no reaction, no reaction. So, definitely, my dear students, what are the two products which examiner is going to ask? One is acetic acid, another one is acetone. ketone. These are the two products. Now, my dear students, if by chance examiner has given compound like this, CH3, CH double bond CH2, and once it has given O3 zinc and water, just compare. And another time he has given O3 and water only. So in the first one, it's very sure that you will get CH3, CH double bond O, CH2 double bond O, no problem. But in second case, this will oxidize to acetic acid. Now we can understand very clearly acetic acid, and this formaldehyde, formic acid, and formaldehyde will convert to formic acid, and then finally carbon dioxide and water. I hope that everyone is able to understand. Just 2-3 minutes more to tell you reductive and oxidative ozonolysis of alkyne. That's it. Alkynes, right? Alkynes ozonolysis. After that, we will complete. Okay, kids? NCN Salmon is saying, Baba, I believed and joined energized batch. But what happened? What happened in energized batch? What happened? Baba is taking classes. Baba is taking classes. What happened to you? Why you are writing like that? Baba is today also Baba has taken class in J energized batch. Yesterday also I have taken classes. Always you are writing like this. Now see kids. Just see. Alkynes ozonolysis. Alkynes. Ozonolysis in alkynes, right? Only 2-3 minutes. If you say RC triple bond CR dash, and if you do reaction O3 zinc, O3 zinc, just see 2 pi bonds are there. In case of alkenes, we have broken pi and sigma because oxygen is in need of 2 bonds. But here, 2 pi bonds will break and we will get simply R C single bond R dash, and we will get compound like this, double bond O, double bond O. It's very simple. See, if you are able to understand. Suppose if I say acetylene, CH triple bond CH. If I say propyne, CH3, C triple bond CH. If I say butane, what answer you are going to get, my dear? Do let me know. So definitely, I'm writing the answer. You just see what answer you are going to get. This case, you will get glyoxyl CHO, CH. This case, you will get CH3, C double bond O, CH double bond O. And this case, you will get CH3, C double bond O, C double bond O, CH3. These are the products you are going to get. Now, alkynes oxidative ozonolysis. Just see alkynes oxidative. Oxidative. See, if I take R1 C triple bond CR, and if I react with O3 and water, so this will get form RC double bond O, C double bond O, R. But my dear students, whether it is aldehyde or ketone, because adjacent carbonyl group are there, they becomes reactive. Adjacent carbonyl groups will become reactive and H2O2 will attack on them, convert into R-COOH, RC. Now, want to understand an example of this? See, if I give you CH3, C triple bond CH, once I'm giving you CH3, C triple bond CH3, I'm going to react it with O3 and water. What I will get? First I will get CH3, C double bond O, C double bond O, H, because unsymmetrical, so it will break from here, will give you 2 carbon acid CH3 COOH, and that will give you 1 carbon acid HCOH, and that HCOH further convert into carbon dioxide water. Gets, so the products in this case will be acetic acid and water, because converting that. And here this is symmetrical. You see, you will get CH3 C double bond O, C double bond O, CH3. Now it will break from here, my dear friends. So symmetrical compound, you will get 2 moles of acetic acid. This completed. Now, one thing you must be thinking, one thing that I will tell you later on, but first of all, let me tell you the note. Let me tell you one note. Note is very, very important note. Like oxidative ozonolysis, we will get same products on reaction with KMNO4 acidic medium or K2Cr2O7 acidic medium. So my dear students, remember this. Just like oxidative ozonolysis we have done of alkene and alkyne, if we react these two reagents on alkene or alkyne, we will get same product. No need to go for this. This is given an NCERT. No need to remember these reactions. Whatever you have done in oxidative ozonolysis, you will get the same product with this also, my dear. Now, you must be thinking one thing in your brain, kids, one thing, that if 2 double bonds are there or 3 double bonds are there, then what we will do? If the reactant is like this, no problem, kids. Whatever the number of double bonds are there, if you reacted with O3 zinc and water, O3 zinc and water, you will get very easily products. You break it from here, you break it from hydrogen. So what do you get? Get CH2 double bond O, CH double bond O, CH double bond O, C double bond O, CH3 and CH3. So this is all about gets. I've told you each and everything. So this is your Baba HSP completed what I have promised. The alkane and the alkene, each and everything I have told you, kids, along with the mind map. Now do let me know in the chat section any doubt, anything. Let me first see the chat section and then only I will complete. Baba, your handwriting is super awesome. Oh my God, invitee then in a platform. Wow, that's really awesome. Thank you. The products. Thank you, Baba. Thank you, kids. Really, you have enjoyed it. Now I will share the PDF in the Telegram. Okay. Thank you, kids. Thank you for your love and support. Now, after this class, next session, I will take which one? Kids, that alkyne and benzene, that electrophilic substitution reaction. That will come after 4 to 5 days. So, after this class, Baba is going to share the PDF in the Telegram. Okay? Baba will share the PDF in the Telegram. Okay? So, good night, kids. Bye to all of you. Love you, kids. God bless you. Bye, kids.